Angular Ascent, a practical guide to building modern web applications. Chapter 1, The World of Modern Web Development and Why Angular. Welcome to the exciting world of modern web development. If you're reading this, chances are you're curious about how today's most dynamic and interactive websites are built, and specifically, how Angular plays a pivotal role in that process. This chapter will paint the big picture, starting with how the web has evolved, introducing you to the concept of JavaScript frameworks, and explaining why Angular is a fantastic choice for building robust and scalable applications. We'll even get your development environment set up and run your very first Angular application. Setting the stage, the evolution of the web. To truly appreciate the power of Angular and other modern web technologies, it's helpful to understand the journey the web has taken. From static pages to dynamic experiences. Imagine the early days of the Internet, sometimes colloquially referred to as Web 1.0. Websites were largely collections of static documents, much like digital brochures. You clicked a link, and your browser fetched an entirely new HTML page from a server, displaying it to you. Each interaction, even something as simple as submitting a comment, typically meant a full page refresh. This was simple but lacked interactivity. The next phase saw the rise of server-rendered pages. Technologies like PHP, ASP.NET, and Java server pages allowed dynamic content generation on the server. When you clicked a button or navigated to a new section, the server would build an entirely new HTML page, populate it with dynamic data, perhaps from a database, and then send that complete page back to your browser. This made the web more functional. Think of early online shopping carts or forums, where each step involved a distinct reload. While more dynamic, the user experience could still feel somewhat clunky and slow due, as the entire page needed to be reloaded and re-rendered for every interaction. Then came the era of what we now call single-page applications, SPAs. Think of Gmail, Google Maps, or social media platforms like Facebook. These applications feel less like traditional websites and more like desktop applications running directly in your web browser. You load them once, and subsequent interactions, whether it's scrolling through your inbox, panning a map, or liking a post, happen almost instantly, without the browser needing to fetch and display an entirely new HTML page. To use an analogy, building a traditional house where each room requires a new blueprint and full construction every time you want to enter it is like a server-rendered application. A single-page application, on the other hand, is like building a modern modular home. The core structure loads once, and then individual rooms or sections are prefabricated and assembled dynamically on site, or even reconfigured instantly as you move through them, without rebuilding the whole house. What is a single-page application? SPA? The core concept of an SPA is that the entire application loads a single HTML page, and then JavaScript dynamically updates parts of that page as the user interacts with the application. When you click a button or fill out a form, the browser communicates with the server in the background, often fetching only the necessary data. And JavaScript then manipulates the existing page to reflect the changes. Benefits of SPAs: faster user experience. After the initial load, subsequent interactions are much quicker because the browser doesn't have to reload entire pages. This leads to a smoother and more responsive feel. Less data transfer. Only the necessary data, e.g., a list of new recipes, is exchanged between the client and server rather than full HTML pages. Better separation of concerns. SPAs naturally encourage a clear separation between the front end, the user interface and client-side logic, and the back end, the data storage, business logic, and API. This makes development and maintenance easier for larger teams. Rich interactions. Easier to build complex UIs with drag-and-drop, real-time updates, and advanced animations. Challenges of SPAs and how they're addressed. Initial load time. The first page load can be slower because the browser needs to download all the necessary JavaScript, HTML, and CSS for the entire application. Modern tools like Angular mitigate this with techniques like lazy loading, where parts of the application are only downloaded when they are actually needed. Search engine optimization, SEO. Historically, search engines struggled to crawl and index content that was dynamically loaded by JavaScript. However, modern search engines, especially Google, have become very adept at executing JavaScript and indexing dynamic content. Server-side rendering, SSR, and pre-rendering are also techniques used to ensure content is available for crawlers. State management. As applications grow, managing what data is where and how it changes can become complex. Frameworks like Angular provide architectural patterns and tools to handle this efficiently. Introduction to JavaScript frameworks. Building a complex single-page application with plain, vanilla JavaScript is possible. But it's like trying to build a skyscraper with only basic hand tools and no blueprint. It would be an incredibly time-consuming, error-prone, and unsustainable effort. This is where JavaScript frameworks and libraries come in. They provide a structured approach, a set of specialized tools, and a collection of conventions that make the process of building sophisticated web applications manageable, scalable, and maintainable. They abstract away much of the underlying complexity, allowing developers to focus on the application's unique features. Today, there are a few dominant players in the front-end JavaScript framework space: Angular, React, and Vue. Each has its strengths, a dedicated community, and a wide adoption in various industries. While this book focuses on Angular, it's worth acknowledging the others as part of the vibrant web development ecosystem. See why choose Angular. Unpacking its strengths. Given the array of choices, why might you choose Angular for your next project, or why is it such an important skill to learn? Google-backed and mature. Angular is developed and maintained by Google. This provides an immense level of stability, long-term support, and confidence in its future. It's a battle-tested framework used not just within Google, but by many large enterprises globally for critical applications. This means a predictable release cycle, comprehensive documentation, and a massive community. Opinionated and structured, Angular is often described as opinionated. This means it provides a very clear, defined way of doing things. While some developers prefer the greater freedom offered by less opinionated frameworks, Angular's structure is a significant advantage, especially for large, complex applications and big teams. It enforces conventions, making it easier for new developers to jump into existing projects and ensuring consistency across different parts of an application. Think of it like having a comprehensive architectural plan for your building before you even lay the first brick. TypeScript at its core, Angular is built from the ground up using TypeScript. What is TypeScript? It's a superset of JavaScript, meaning all valid JavaScript code is also valid TypeScript code. However, TypeScript adds optional but powerful static typing. You can think of it as JavaScript with superpowers. Benefits: TypeScript catches many common programming errors during development before you even run your code, rather than at runtime. This dramatically reduces bugs. It also provides excellent tooling support in code editors like auto-completion, intelligent code navigation, and refactoring, and significantly improves code readability and maintainability, especially in large and complex applications where understanding different data structures is crucial. Component-based architecture. At the heart of Angular applications is a component-based architecture. This means your applications are built from small, reusable, and self-contained units called components. Each component controls a specific part of the user interface and its associated logic. For example, a navigation bar, a user profile card, a product item, or a search bar could each be their own component. This modularity makes applications easier to build, test, maintain, and scale, much like assembling a complex machine from individual interchangeable parts. Dependency injection, DI. Dependency injection is a fundamental design pattern actively used by Angular. It's a highly effective way of building applications where different parts, components, services, etc., can easily get the dependencies or services they need without having to create or manage those dependencies themselves. It promotes modularity, testability, and reusability of code. It's like a sophisticated catering service that brings exactly the ingredients your kitchen, component, needs, rather than you having to go find and manage them yourself. Rich ecosystem and tools. Angular isn't just the core framework. It comes with a powerful set of integrated tools and libraries that work seamlessly together. Angular CLI, a command line interface tool that automates many development tasks. Angular Router, for managing application navigation and mapping URLs to different views. HTTP Client, for easily communicating with backend APIs. Angular Material, a UI component library that implements Google's material design, providing pre-built, accessible, and performant UI elements. This comprehensive ecosystem means you often don't need to hunt for external libraries for common tasks, leading to more consistent and maintainable codebases. Performance focus. Angular is built with performance in mind. It includes features like ahead-of-time AOT compilation. Angular compiles your code before the browser sees it, which speeds up rendering. Tree shaking removes any unused code from your final application bundle, making it smaller and faster to download. Lazy loading allows you to load parts of your application only when they are needed, significantly reducing initial load times for larger apps. Setting up your development environment. Before we dive into writing Angular code, we need to set up your development environment. This involves installing a few key tools: Node.js and NPM. Angular's build tools run on Node.js. Node.js is a JavaScript runtime environment that allows you to run JavaScript code outside of a web browser, on your computer's operating system, for example. We'll use Node.js to execute various scripts and tools that help in Angular development. NPM Node Package Manager comes bundled with Node.js. It's the default package manager for Node.js, acting like an app store for JavaScript libraries, frameworks, and development tools. We'll use NPM to install the Angular command line interface, CLI, and other project dependencies. Installation steps for Node.js and NPM. Go to the official Node.js website, nodejs.org. Download the LTS long-term support version. This is the recommended stable version for most users. Run the installer and follow the on-screen prompts. Accept the default settings. Verify installation. Open your computer's terminal or command prompt on Windows, sometimes called PowerShell or command prompt. On Mac OS Linux, just terminal. Type the following commands and press enter after each. Node v. This should display the Node.js version you installed, e.g., v18.17.0. npm v. This should display the npm version, e.g., 9.6.7. If you see version numbers, you're good to go. Angular CLI, command line interface. The Angular CLI is your best friend when working with Angular. It's a powerful command line tool that automates repetitive development tasks. It can create new Angular projects, generate components, services, and modules, run tests, serve your application locally, and build your application for deployment. It's like having a robotic assistant that handles all the repetitive setup for you. Installation steps for Angular CLI. Open your terminal or command prompt. Run the following command. npm install g@angular/cli. The G flag stands for global, meaning this tool will be installed on your system as a whole, allowing you to use the ng command, Angular CLI's primary command, from any directory. Verify installation. Once the installation completes, type ng version. This will display information about your Angular CLI version, Node.js version, and other related packages. Visual Studio Code, VS Code. While you can use any text editor for Angular development, Visual Studio Code, VS Code, is highly recommended. It's a free, open-source, and incredibly powerful integrated development environment, IDE, developed by Microsoft. It has excellent built-in support for TypeScript, a vast ecosystem of extensions, and deep integration with Angular development. Installation steps for VS Code. Go to the official VS Code website, code.visualstudio.com. Download and install the version appropriate for your operating system. Recommended extensions. Once VS Code is installed, open it. Go to the Extensions view. You can click the square icon on the sidebar or press Ctrl+Shift+X/CMD+Shift+X. Search for and install the following extensions, which will greatly enhance your Angular development experience. Angular Language Service provides intelligent code completion, error checking, and navigation within Angular templates. Prettier code formatter helps format your code consistently. Ease lint if you plan to use it for linting, for enforcing code quality and style. Your first Hello Angular application. Now that your environment is set up, let's create and run your very first Angular application. Open your terminal command prompt. Navigate to a directory where you want to create your new project. For example, you might create a new folder called Angular Projects and then cd into it. Create a new Angular project. Run the following command. ng-new my first Angular app strict routing. Let's break down this command. ng-new, this is the Angular CLI command to create a new Angular project. My first Angular app, this is the name of your project. The CLI will create a new directory with this name. Strict, this flag enables stricter type checking and build optimizations in your project. It's a best practice for cleaner, more robust code. Routing, this flag automatically sets up the Angular router, which is essential for navigation in multi-page applications. Even though in SPA loads only one HTML page, it might display different content based on the URL. When you run this command, the Angular CLI will ask you a question. Would you like to add Angular routing? YN. Since we included routing, it will default to Y, so you can just press enter. Then it will ask, which stylesheet format would you like to use? Use arrow keys. You'll see options like CSS, SCSS, SAS, LESS. For this book, we will generally use CSS, so select CSS using your arrow keys and press enter. The Angular CLI will then get to work. It will create the project directory, set up the entire project structure, install all the necessary dependencies, Node.js packages, configure TypeScript, and even set up basic routing. This process might take a few minutes depending on your internet speed. Navigate into your project directory. Once the ng-new command completes, you'll see a new folder created with your project name. You need to change into that directory in your terminal. cd my first Angular app. Run your Angular application. Now, let's start the development server and see your application in action. ng-serve open. ng-serve. This command compiles your Angular application code, starts a local web development server, usually on HTTP localhost :4200, and watches for any changes you make to your code. If you save a file, it will automatically recompile and refresh your browser. Open. This flag tells the CLI to automatically open a new tab in your default web browser to the application's URL, e.g., HTTP localhost :4200. After a short compilation time, your browser should open and display the default Angular welcome page. This page contains links to Angular resources and a visual representation of the Angular logo. This is your first Angular application running successfully. Common pitfalls / troubleshooting, Chapter 1. Even with careful instructions, setting up development environments can sometimes lead to minor hiccups. Here are a few common issues and their solutions. Node or npm command not found. Problem. This usually means Node.js wasn't installed correctly or its installation directory isn't in your system's path environment variable. Solution. Double-check that you ran the Node.js installer successfully. On Windows, you might need to restart your terminal or even your computer for changes to the path variable to take effect. If problems persist, consider uninstalling and reinstalling Node.js, ensuring you download the LTS version. Some advanced users might consider Node Version Manager, NVM, for managing multiple Node.js versions. ng command not recognized. Problem. Similar to the above, this means the Angular CLI wasn't installed correctly or its global installation path isn't in your system's path. Solution. Ensure you ran npm install /Angular/cli without any errors. If it failed, try running it again. If you're on a Linux or Mac OS system, you might need to use sudo before the command e.g. sudo npm install /Angular/cli to grant necessary permissions, though this is less common with modern npm versions. ng-serve fails with port 4200 is already in use. Problem. This happens if another application on your computer is already using the default port 4200 that Angular's development server tries to use. This could be a previous Angular app you didn't close or another web server. Solution: you can tell Angular to use a different port by adding the port flag, ng serve port 4201. This will start your application on HTTP localhost :4201. You can choose any unoccupied port. Alternatively, you can identify and close the application using port 4200 if you know what it is. Slow ng new installation. Problem: the initial ng new command involves downloading many packages, which can take a while if your internet connection is slow or if npm's registry is temporarily busy. Solution: be patient. It's normal for it to take a few minutes. Ensure you have a stable internet connection. If it consistently fails or takes an extremely long time, you might have network issues or npm configuration problems, e.g., a proxy server. Further reading/resources, Chapter 1. While this book aims to be comprehensive, the best way to master Angular is to explore its official documentation and community resources. Official Angular documentation. Angular.io, this is the authoritative source for everything Angular. Node.js official website, nodejs.org, for Node.js downloads and documentation. TypeScript official website, typescriptlang.org, for getting a deeper understanding of TypeScript. Visual Studio Code, code.visualstudio.com, for downloading the editor and exploring its features and extensions. With your development environment now set up and your first Angular application running, you've taken a significant step into the world of modern web development. In the next chapter, we'll begin to dismantle that Hello Angular application and understand its core building blocks. Components, templates, and data binding. Chapter 2, Angular Fundamentals, Components, Templates, and Data Binding. In the previous chapter, we set up our development environment and launched our first Angular application. You saw a default welcome page that appeared as if by magic. Now, it's time to reveal the core concepts that power this magic. This chapter will introduce you to Angular's foundational building blocks, components, how they interact with their visual templates, and the essential mechanism of data binding that bridges the gap between your application's logic and its user interface. Components, the building blocks of your application. If you think of a large, complex Angular application as a sophisticated piece of architecture like a modern building or a complex machine, then components are your individual, self-contained, and interchangeable Lego bricks. Each component is responsible for a specific part of the user interface, UI, and its associated behavior and logic. The component concept: imagine a website for a recipe book. You might have components for navigation bar, displays the site logo, navigation links, and a search bar. Recipe card shows a single recipe's image, title, and a short description. Recipe detail view displays all the information for a specific recipe, including ingredients and instructions. User profile shows user-specific information. Each of these is a distinct, logical unit. By breaking down your application into these smaller, more manageable pieces, development becomes more organized, easier to test, and more scalable, especially in larger teams where different developers might work on different components concurrently. Anatomy of an Angular component. Every Angular component is typically composed of at least 3 core files working together. The TypeScript class, TS file, this is the brain of your component. It's a standard TypeScript class that defines the component's data, called properties, and its behavior, called methods. Properties, variables that hold data relevant to the component. For a recipe card component, properties might include recipe title, recipe image URL, or preparation time. Methods, functions that perform actions. For instance, a recipe card might have a view recipe details method that navigates to a detailed view when the user clicks on the card. The template, HTML file. This is the face or visual representation of your component. It describes what the component looks like on the screen. It's largely standard HTML, but with Angular's special syntax to display data from the component's TypeScript class, handle user interactions, and dynamically control the layout. The stylesheet, CSS, SCSS or less file. This file contains the CSS rules that define the appearance, colors, fonts, layout specific to this particular component. A key feature of Angular is that these styles are automatically scoped to the component. This means the CSS you write for one component will not accidentally affect or interfere with the styling of other components in your application, promoting design consistency and avoiding unexpected styling conflicts. The @component decorator. While not a separate file, the @component decorator is crucial. It's a special function, prefixed with that you attach to your TypeScript class. This decorator is how you tell Angular that this class is a component and provide essential metadata about it. Key properties within the decorator include selector. This defines the custom HTML tag you'll use to place your component in other HTML templates. For example, if a component selector is app_recipe_card, you'll use app_recipe_card in your HTML to render it. Template URL. This specifies the path to the HTML template file associated with this component. Style URLs. This is an array of paths to the stylesheet files that apply to this component. Data binding. Connecting logic and Data binding is one of Angular's most powerful features. It's the mechanism that synchronizes data between your component's TypeScript logic and its HTML template, making your application dynamic and interactive. Imagine a two-way radio connecting your brain, the component's logic to your hand, the template's display. Angular offers several types of data binding, often categorized by the direction data flows. 1. Interpolation, one way. Component to HTML. Syntax, double curly braces, expression. Purpose, to display a component property's value directly as text within the HTML template. It's like filling in a blank on a form. The data flows from the component to the template, rendering it as plain text. Analogy, a digital display board updating with the latest information from a central office. Example, conceptual. If your recipe card component has a property recipe title set to classic margarita pizza, then using recipe title in its template would display classic margarita pizza. H1, recipe title /H1. Span preparation time minute span. 2. Property binding, one way. Component to HTML. Syntax, square brackets target property equals expression. Purpose, to bind a component property's value to an HTML element's property, not necessarily an attribute, though it often involves attributes. This allows you to dynamically control HTML attributes, CSS styles, or even input values for other components. It's like setting a specific instruction or configuration on an object based on your component's current state. Analogy, painting a block of text blue if a highlight setting is turned on. Example, conceptual, to set the src attribute of an image dynamically based on a recipe image URL property from your component. Img src equals recipe image URL, alt equals image of recipe title. Note, we are still using interpolation inside the alt attribute value. To disable a button based on a isButtonDisabled property in your component. Button disabled equals isButtonDisabled submit recipe button. If isButtonDisabled is true, the button will appear grayed out and be unclickable. 3. Event binding, one way. HTML to component. Syntax, parentheses target event, handler method. Purpose, to listen for DOM events, like clicks, key presses, form submissions on an HTML element and execute a method within your component as a response. The data flows from the template to the component. It's like pressing a button on a remote control to trigger an action on a device. Analogy, a doorbell button that triggers a chime inside the house. Example, conceptual. To call a onViewDetails method in your component when a button is clicked. Button click equals onViewDetails, view recipe details button. To capture the value typed into an input field as it changes and pass it to a component method. Input equals update search term $event target value. Note, event is a special variable that represents the DOM event object. Event target refers to the element that triggered the event, and value accesses its current value. 4. Two-way data binding, combined. Component to HTML and HTML to component. Syntax, banana in a box ng model, equals property name. Purpose, this is a convenient combination of property binding and event binding, primarily used with HTML form input elements. It ensures that the component's property and the input element's value are always in sync. If the component's property changes, the input field updates. If the user types into the input field, the component's property updates automatically. It's like a two-way mirror, reflecting changes in both directions instantly. Important note, to use ng model, you must import Angular's forms module into your application's module file. We will cover modules and forms in more detail in later chapters. Example, conceptual. For a text input where you want the user's name to be immediately available in your component's username property and vice versa. Input type equals text. ng model equals username. If you typed Alice into the input, the username property in your component would become Alice. If your component programmatically changed username to Bob, the input field would automatically update to Bob. See lifecycle hooks. When Angular does what? Components don't just appear and disappear. Like living organisms, they go through a specific life cycle. They are created, rendered on the screen, potentially updated multiple times, and eventually destroyed when they are no longer needed. Angular provides special methods called lifecycle hooks that allow you to tap into these key moments in a component's lifecycle. ng on init. This is by far the most commonly used lifecycle hook. It's called once after Angular has initialized all data-bound properties of a component. This makes ng on init the ideal place to perform initial data setup, fetch data from a server, like loading recipes from an API, or do anything that needs to happen once the component has been set up, but before it begins rendering its content to the user. It effectively marks the component's initialization ceremony or its readiness. The ng on init method is part of an interface called onInit. To use it, you implement this interface in your component class. Example, conceptual. Import component onInit from @Angular core, @component. Selector @recipe list. Template URL, recipe-list.component.html. Style URLs, /recipe-list.component.css. Export class recipe list component implements onInit. Recipes, string equals, a property to hold recipe titles. Constructor, console log, constructor says. Component created, but properties not yet set. ng on init, void. Console log, ng on init says, component properties are now initialized. Time to fetch data. In a real app, you might fetch data from a backend here. This recipes equals spaghetti carbonara, chicken curry, vegan chili. This conceptual example demonstrates the sequence. The constructor runs first, before properties are fully initialized by Angular, and then ng on init runs, making it the safe place for initial data loading. Practical component example. The recipe item. Let's put these concepts into a simple hypothetical recipe item component for our recipe book application. Scenario. We want a component that displays a single, concise recipe item in a list. It will show the recipe's title, an image, and allow the user to mark it as a favorite. Component logic recipe-item.component.ts conceptual description. Inside the recipe item component class. Recipe title, string equals spaghetti carbonara, recipe image URL, string equals assets-carbonara.jpg, is favorite, boolean equals false, toggle favorite. Void, this is favorite equals, this is favorite, toggles the boolean value. Console log $this recipe title is now favorite, this is favorite. This component defines three properties: recipe title, recipe image URL, and is favorite. It also has one method, toggle favorite, which flips the is favorite property between true and false. Template HTML, recipe-item.component.html, conceptual description. Div class equals recipe card. Img src equals recipe image URL, alt equals image of recipe title, class equals recipe image. H3 class equals recipe title H. Button class equals favorite button, click equals toggle favorite. Mark as is favorite. Unfavorite, favorite. Button. Span ng if equals is favorite, class equals favorite indicator star your favorite, /span. Div. Here's how data binding is used. src equals recipe image URL. Property binding sets the src attribute of the image dynamically. Alt equals image of recipe title. Interpolation displays the recipe title inside the alt text. Recipe title. Interpolation displays the recipe's title. Click equals toggle favorite. Event binding calls the toggle favorite method in the component when the button is clicked. Is favorite, unfavorite, favorite. Interpolation uses a simple conditional, ternary, operator to display different text on the button based on the isFavorite status. Span ng if equals is favorite. This introduces a structural directive, ngIf, which we'll cover in detail in the next chapter. For now, understand that this span element and its content will only be added to the HTML if isFavorite is true. Styling recipe-item.component CSS, conceptual description, recipe card, border 1px solid CCC, padding 15px, margin 10px, border radius 8px text-align, center, box shadow 2px 8px RGBA 0000.1. Recipe image, max width 100%, height 150px, object fit, cover, border radius 4px, margin bottom 10px. Recipe title, color 333, font size 1.2 margin bottom 10px. Favorite button, background color #007 BFF, color, white padding 8px 15px, border none, border radius 5px, cursor, pointer. Favorite button, hover, background color 56B3. Favorite indicator, display, block, ensures it's on a new line. Color FFC 107, a gold-like color for the star. Margin top 5px, font weight bold. This CSS provides basic styling for our recipe item component, making it visually appealing. This recipe item component demonstrates how the TypeScript class provides the data and functions. The HTML template uses data binding to display that data and react to user input, and the CSS styles its appearance, all as a self-contained unit. Common pitfalls / troubleshooting, Chapter 2. Syntax confusion. Problem: a common mistake for beginners is mixing up interpolation, property binding, and event binding syntax. Solution: remember their distinct roles. Property, for displaying text content in the template, component to HTML. Property equals expression, for setting element properties or attributes dynamically, component to HTML. Event equals method, for reacting to user interactions or DOM events, HTML to component. ng model equals property, for two-way data binding, mainly with form inputs. ng on init v's constructor, problem. Developers sometimes put logic that depends on Angular initialized properties in the component's constructor. Solution: the constructor is primarily for simple initialization, like injecting services, which we'll cover later. Any logic that relies on the component's data-bound properties being available or needs to be executed once the component is ready after its creation should go into ng on init. Angular guarantees that all inputs have been set when ng on init is called. ng model, not working error, can't bind to ng model since it isn't a known property. Problem: this error occurs when you try to use ng model, but haven't imported the forms module into the Angular module, app module by default, where your component is declared. Solution: open your src/app/app module ts file and add import forms module from @Angular forms at the top. Add forms module to the imports array within the @ng module decorator. F. Further reading / resources, Chapter 2. To deepen your understanding of these fundamental concepts, consider exploring Angular documentation on components, angular.io/guide/component-overview. Angular documentation on data binding, angular.io/guide/binding-syntax, Angular lifecycle hooks guide, angular.io/guide/lifecycle-hooks. You've now learned about the foundational pieces of any Angular application, components, their structure, and how they interact with the view through various forms of data binding. In the next chapter, we'll build on this knowledge by exploring directives and pipes, which allow you to manipulate your templates dynamically and transform data for display. Chapter 3, Directives, Pipes, and More on Templates. In the previous chapter, we dissected the Angular component and learned how data flows between its logic and its HTML template using data binding. That's a powerful start, but Angular offers even more sophisticated tools to make your templates dynamic and responsive. This chapter introduces directives, which allow you to enhance HTML elements with special behaviors or modify the structure of your DOM, and pipes, which transform data for display without altering the underlying data itself. Directives, enhancing HTML with Angular logic. At its simplest, a directive is a special instruction in the DOM that tells Angular to attach behavior to an element or a component, or to transform the DOM. Think of them as special labels or flags you add to your regular HTML tags to make them smarter or more interactive. In fact, components, which we discussed in Chapter 2, are technically a type of directive called component directives. However, Angular provides two other crucial categories of directives that are used extensively for controlling the appearance and behavior of your templates: structural directives and attribute directives. 1. Structural directives. Purpose. These directives dramatically change the structure or shape of the DOM by adding, removing, or manipulating elements. They are easily recognized by the asterisk prefix in front of their name. Think of them as controlling whether a part of your building exists or how many copies of it there are. The asterisk prefix. The asterisk is Angular's syntactic sugar for a more verbose ng template element. It tells Angular that this directive will manipulate the DOM itself, not just an attribute or style. Let's explore the most common structural directives. Ng if conditional rendering. Functionality. This directive adds or removes an entire element and its contents from the DOM based on whether a given Boolean expression is true or false. If the expression evaluates to true, the element exists in the HTML. If false, it's completely gone from the HTML, not just hidden with CSS. Analogy. Imagine a secret door in a wall. When the condition ng if equals door open is met, the door appears, otherwise it's just a blank wall. Example, conceptual description. Let's say in our recipe book app, we want to show a loading message only when the isLoading property in our component is true. Div ng if equals isLoading, loading recipes. Please wait div. Div ng if equals isLoading recipe list loaded /div. When isLoading is true, only the first div will be present in the actual browser's DOM. When isLoading is false, only the second div will be there. With an else block, ng if can also define an else template to display when the condition is false. This uses the ng template element, which is a special Angular element that is never rendered directly in the DOM, but rather helps Angular structure content. Div ng if equals recipes found, else no recipes. Content to display if recipes found is true. P here are your delicious recipes, /p. Div ng template no recipes. Content to display if recipes found is false. P no recipes, found matching your criteria P. ng template. Here, no recipes is a template variable, which we'll discuss later in this chapter. ng for list rendering, functionality. This directive is used to render a list of items by repeating a part of the HTML template for each item in a collection, typically an array. Analogy. Using a stencil repeatedly to draw the same shape for each item on a list. Syntax. Asterisk the basic syntax is ng for equals let item of items. Example, conceptual description. Let's say we have an array called recipes in our component, and each item in this array has a title property. To display a simple list of recipe titles, ul, li ng for equals, let recipe of recipes. A recipe title, li, ul. For each recipe in the recipes array, a new li element will be created, and the recipe title will be displayed inside it. If recipes had 3 entries, 3 li elements would appear. Exported variables. ng for also provides several local template variables you can use within the loop for more control. Index as I. The current item's index, 0-based. First as is first, true for the first item. Last as is last, true for the last item. Even as is even, true for even-indexed items. Odd as is odd, true for odd-indexed items. These are useful for applying conditional styling, e.g. ng class equals. Highlight row is even or displaying unique content for the first-last items. ng switch multiple conditional rendering, functionality. Similar to a switch statement in programming, ng switch displays one of several elements based on a match for a given value. It's useful when you have multiple, mutually exclusive conditions that determine what content to display. Analogy: a display board at a train station that shows different messages, e.g., arriving, delayed, departed, based on the train's current status. Example: conceptual description. Imagine displaying different UI sections based on a user role property in your component. Div ng switch equals user role. Div ng switch case equals admin welcome administrator. You have full access div. Div ng switch case equals editor hello editor. You can modify content div. Div ng switch case equals viewer greetings viewer. You can read articles div. Div ng switch default please log in to see content div. Div. Only the div whose ng switch case value matches user role will be rendered. If no match is found, the ng switch default content is displayed. 2. Attribute directives. Purpose. Unlike structural directives, which manipulate the DOM structure, attribute directives change the appearance or behavior of an element or component without adding or removing elements. They typically look like standard HTML attributes. Think of them as adding an extra coat of paint, a special sticker, or a new piece of hardware to an existing item without changing its fundamental form. Let's look at some frequently used attribute directives. ng class, dynamic classes. Functionality, dynamically adds or removes CSS classes from an element based on conditions. This is incredibly useful for applying different styles based on the component's state. Analogy, changing a person's outfit based on the current weather, e.g., a winter coat class for cold weather. Syntax. ng class equals class name 1, condition 1, class name 2, condition 2, or ng class equals class 1, class 2, or ng class equals my class's object. Example: conceptual description. In our recipe item component, we might want to highlight a recipe if it's currently selected, or if it's considered premium. Div class equals recipe card. ng class equals selected is selected premium recipe. Recipe is premium. Recipe card content goes here. Div. If is selected is true, the selected CSS class will be added to the div. If recipe is premium is true, the premium recipe class will be added. ng style, dynamic inline styles. Functionality, dynamically applies inline CSS styles to an element. Useful for setting styles programmatically. Analogy, adjusting the color and size of a light bulb based on user preferences. Syntax, ng style equals CSS property. Value, another property, component property. Example: conceptual description. Setting the background color of a recipe card based on its category or a font size based on a setting. Png style equals background color. Recipe.category color, font size px, font size. This text is styled dynamically, p. Here, recipe.category color and font size would be properties in your component. Angular automatically handles adding px for pixel values when you use the dot notation font size px. Creating custom attribute directives. While Angular provides a rich set of built-in directives, you also have the power to create your own. When you find yourself repeating the same DOM manipulation logic or behavior across different components, e.g., a custom tooltip, a highlight on hover effect, or a drag-and-drop handler, a custom attribute directive is a perfect tool to encapsulate and reuse that logic. For instance, you could create an app highlight directive that changes the background color of an element when hovered over. This topic, however, is typically covered in more advanced Angular books or later stages of learning. B-pipes. Transforming data for display. Definition. Pipes are small, pure functions that you use directly within your templates to transform data right before it is displayed to the user. They don't change the underlying data itself in your component, they only modify its presentation in the template. Think of them as a filter that cleans, reformats, or otherwise processes something before it's presented to you. Why use pipes? Clean templates. They keep your templates concise and readable by moving data formatting logic out of your component's TypeScript file. Separation of concerns. They help separate the logic of how data is handled from the logic of how it's displayed. Reusability. Once a pipe is defined, you can use it anywhere in your templates. Syntax. You apply a pipe using the pipe symbol, followed by the pipe's name. You can also pass arguments to a pipe using a colon. Common built-in pipes. Angular provides many useful built-in pipes. Date formats a date value according to locale rules. Example, today date, short time, e.g. 3:45 p.m. Example, recipe at a date, medium date, e.g. Oct 28, 2023. Example, last updated date, YIMMDD, e.g. 2023 to 10 to 28. Currency formats a number as a currency string. Example, item price currency, USD, e.g. $20.99. Example, ingredient cost currency, your symbol, e.g. €5.50. Example, total cost currency, GBP code 1.2 to 2, e.g. GBP 50.12, showing 2 decimal places. Uppercase and lowercase transforms text to all uppercase or all lowercase letters. Example, page title uppercase, e.g. MY recipe book. Example, username lowercase, e.g. John Doe. JSON converts a JavaScript object into a JSON string. This is incredibly useful for debugging, as it allows you to see the raw data structure of any object directly in your template. Example, recipe details JSON, the pre tag preserves formatting. Slice extracts a portion of a string or an array, similar to JavaScript slice, method. Example, recipe.description slice shows only the first 100 characters of a long description. Example, limited ingredients slice, 5 shows ingredients from index 2 up to, but not including index 5. Percent formats a number as a percentage string. Example, completion progress percent, e.g., if completion progress is 0.75, it displays 75%. Chaining pipes. You can combine multiple pipes by chaining them together. The output of one pipe becomes the input for the next pipe, and transformations occur from left to right. Example, welcome to our recipe app, uppercase slice. First, welcome to our recipe app becomes welcome to our recipe app, uppercase pipe. Then, welcome to our recipe app is sliced to welcome to our slice pipe, creating custom pipes. Sometimes, the built-in pipes won't cover a specific formatting need. In such cases, Angular allows you to create your own custom pipes. You define a class with the @pipe decorator and implement an iTransform interface, which requires a transform method. This method takes an input value and any optional arguments and returns the transformed value. For example, you could create a custom pipe called shorten that takes a string and a limit, and if the string is longer than the limit, it truncates it and adds an ellipsis. Your template might then use it like long recipe instructions, shorten 200. This would display the first 200 characters of the instructions followed by see template variables, referencing elements in your template. Definition. A template variable is a way to get a reference to a DOM element, a component, or a directive instance directly within your template. You declare a template variable using the hash symbol, followed by the variable name. It's like giving a temporary nickname to a specific element in your view. Why use template variables? Template variables are useful when you need to access properties or call methods on an element or component that is defined within your template. Use cases. Accessing input values. A very common use case is to get the current value of an input field without relying on two-way data binding, ng model, or event binding. Example, conceptual description. Input recipe name input type equals text, placeholder equals enter recipe name. Button click equals add recipe, recipe name input value. Add recipe but. PU entered. Recipe name input value, P. Here, hash recipe name input creates a template variable that refers to the input element. We can then access its value property when the button is clicked or display it in a paragraph. Calling methods on child components. If you have a child component embedded in your template and it exposes public methods, you can call them directly from the parent's template using a template variable. Example, conceptual description. If a child component AppTimer has a public start method, AppTimer myTimer component AppTimer. Button click equals myTimer component start timer button. Interacting with ng form, covered later. When working with forms, template variables are essential for accessing the form's state, e.g., whether it's valid, dirty, or untouched, and its controls. Common pitfalls / troubleshooting. Chapter 3. Forgetting for structural directives. Problem: using ng if equals is valid instead of ng if equals is valid. Solution: remember that is crucial for structural directives like ng if, ng for, and ng switch case, because it signals that the directive will modify the DOM-S structure, placing multiple structural directives on one element. Problem: you cannot use ng if and ng for on the same HTML element directly. Angular needs to determine the element's existence, ng if, before it can decide to repeat it, ng for. Solution: use an ng container or a wrapper div. An ng container is an Angular-specific element that is a logical grouping, but does not add an extra element to the rendered DOM, making it ideal for this scenario. Correct way with ng container. Ng container ng if equals show recipes. Div asterisk ng for equals let recipe of recipes. Recipe title. Div ng container. Creating custom pipes error. Pipe my custom pipe could not be found. Problem: after creating a custom pipe, you see an error indicating it's not found. Solution: you need to declare your custom pipe in the declarations array of the ng module where you intend to use it, typically app module ts for pipes that are used across the application, or a specific module for feature-specific pipes. Date formatting errors with date pipe. Problem: the date pipe might not display the date in the expected format. Solution: refer to the Angular documentation for datepipe angular.io/api/common/datepipe to ensure you are using the correct format strings, e.g., short date, yimmddh. Misunderstanding pipe purity, though this is more advanced. Problem: a pipe might not rerun when you expect it to, particularly if the input object's internal properties change, but the object reference itself does not. Solution: by default, pipes are pure, meaning they only re-execute if their input value or parameters change. This is for performance. For more complex scenarios where you need a pipe to reevaluate frequently, e.g., when an object's internal state changes, you might need an impure pipe, but these should be used sparingly as they can impact performance. This concept is for deeper technical discussion beyond this beginner guide. Further reading/resources, Chapter 3. Angular documentation on structural directives. Angular.io/guide/structural-directives. Angular documentation on attribute directives. Angular.io/guide/attribute-directives. Angular documentation on pipes. Angular.io/guide/pipes. Angular built-in pipes reference. Angular.io/api/common hash pipes for a comprehensive list. You now have a robust understanding of how to control the structure of your templates with structural directives, and how to modify the appearance and behavior of elements with attribute directives. You've also learned how to elegantly transform data for display using pipes. These tools give you immense power to create dynamic and user-friendly interfaces. In the next chapter, we'll dive into how components communicate with each other, which is crucial for building larger, more interconnected applications. Chapter 4. Component Communication. Building Interconnected Applications. In the last two chapters, we explored components as self-contained units and how to make their templates dynamic. However, real-world applications are rarely just a collection of isolated components. Instead, components need to interact, share data, and respond to events from each other. This chapter focuses on the fundamental patterns for component communication in Angular, which is essential for building interconnected and functional applications. We'll primarily look at how parent components communicate with child components, and vice versa, as this is the most common scenario. A parent-to-child communication. At input, decorator. The most straightforward way for components to communicate is from a parent component passing data down to a child component. This is achieved using the at input decorator concept. Think of a parent component as a director and a child component as an actor. The director gives the actor a script, data, written by the director. The actor performs based on that script, but doesn't dictate the script itself. At input, property in a child component acts like a public property or an input slot through which the parent can provide values. How it works. The child component declares a property decorated with that input. This signals that this property can receive data from its parent. The parent component then binds a value from its own properties or expressions to this child component input property using property binding, square brackets, in its template. Example, passing recipe details to recipe item component. Let's refine our recipe item component from Chapter 2. Instead of hard-coding recipe title and recipe image URL within the recipe item component itself, a parent component, perhaps a recipe list component, should provide this data. One child component recipe-item.component.ts. Import component input from @Angular core @component. Selector @recipe item. Template URL recipe-item.component.html. Style URLs recipe-item.component.css. Export class recipe item component. Declare properties as inputs. Add input recipe title. String initialize with empty string. Add input recipe image URL. String add input is favorite, boolean equals false. Now it's also an input. The toggle favorite method is still internal to the child, but the initial state comes from the parent. Toggle favorite void. This is favorite equals this is favorite. Console log $this recipe title, favorite status changed to this is favorite. Later, we might want to tell the parent about this chain. Here, recipe title, recipe image URL, and is favorite are now inputs. The @input decorator indicates they are expected to receive values from the outside. 2. Parent component recipe-list.component.ts. Let's assume our recipe list component has an array of recipes data. Import component on_init from @Angular core. Interface recipe. Define a simple structure for our recipe objects. Title string image URL. String favorite boolean. @component. Selector. @recipe list. Template URL. recipe-list.component.html. Style URLs. recipe-list.component.css. Export class recipe list component implements on_init. Recipes. Recipe equals title spaghetti carbonara image URL. Assets carbonara.jpg favorite false. Title chicken curry image URL. Assets chicken-curry.jpg favorite true. Title vegetable soup image URL. Assets veg-soup.jpg favorite false. Constructor ng on_init void. 3. Parent component template recipe-list.component.html. To render each recipe item component within the list, we would use ng for and bind the properties from each recipe object to the inputs of @recipe item. H to our delicious recipes, H2. Div class equals recipe grid. @recipe item. ng for equals let recipe of recipes. Recipe title equals recipe title. Recipe image URL equals recipe image URL. Is favorite equals recipe favorite @recipe item. Div. In this parent template, for each recipe object in the recipes array, we create an @recipe item instance. We then use property binding to pass the recipe title to the child's recipe title input, recipe image URL to recipe image URL, and recipe favorite to his favorite. B. Child to parent communication. @output, decorator with event emitter. Now, what if a child component needs to notify its parent about something that happened? For example, if the recipe item components is favorite status changes, the parent recipe list component might need to update its underlying recipes data to reflect this. This is achieved using the @output decorator combined with Angular's event emitter. Concept. Going back to our director-actor analogy, if the director parent gives the script data to the actor child, then when the actor child performs an action that needs to be known by the director, the actor sends a signal or makes a sound, an event. The director listens for that signal and then reacts accordingly. And @output, property in a child component creates a custom event that the parent can listen for. How it works. The child component declares a property decorated with @output. Its type must be event emitter. When an event occurs in the child, e.g., a button click, the child component calls the emit method on its event emitter property, optionally passing data along with the event. The parent component then listens for this custom event using event binding parentheses in its template, just like it would listen for a standard HTML event, click, and executes a method when the event fires. Example, alerting the parent when favorite status changes. Let's modify our recipe item component so that when toggle favorite is called, it informs its parent. One child component, recipe-item.component.ts. Import component, input, output, event emitter from @Angular core, @component. Selector, @recipe item. Template URL, recipe-item.component.html. Style URLs, /recipe-item.component.css. Export class recipe item component. @input, recipe title, string @input. Recipe image URL, string @input, is favorite. Boolean equals false, still an input for initial state. Declare an output property, an event emitter that emits the recipe title. At output, favorite status changed equals new event emitter string, toggle favorite. Void, this is favorite equals, this is favorite, change internal state. Console log $this recipe title, favorite status changed internally. Emit an event to the parent, passing the recipe title. This favorite status changed emit, this recipe title. Here, favorite status changed is our new output. It's an event emitter that will emit a string, the recipe title in this case. 2. Parent component template, recipe-list.component.html. The parent listens for the favorite status changed event on each recipe item and calls a method in its own component, passing the event, which will be the recipe title emitted by the child. H2R delicious recipes, H2. Div class equals recipe grid. Recipe item. ng for equals let recipe of recipes. Recipe title equals recipe title. Recipe image URL equals recipe image URL. Is favorite equals recipe favorite. Favorite status changed equals on child favorite change $event. Listen to the custom event. Recipe item. Div. The parent component now uses favorite status changed to bind to the output event. When the child emits, the parent's onChild favorite change method is called, receiving the emitted data, the recipe title. 3. Parent component recipe-list.component.ts. The parent component needs a method to handle the event emitted by the child. Import component onInit from @Angular core, interface recipe, title string image URL, string favorite Boolean. @component, selector recipe list, template URL, recipe-list.component.html, style URLs, recipe-list.component.css. Export class recipe list component implements onInit. Recipes. Recipe equals title spaghetti carbonara image URL, assets carbonara.jpg favorite false, title chicken curry image URL, assets chicken-curry.jpg favorite true, title vegetable soup image URL, assets veg-soup.jpg favorite false, constructor ng onInit. Void method to handle the event from the child. On child favorite change recipe title string void. Find the recipe in our array and update its favorite status. Const index equals this recipe's find index. R equals R title equals recipe title. If index equals this recipe's index, favorite equals this recipe's index. Favorite, console log parent, favorite status for recipe title, updated. The onChild favorite change method receives the recipe title from the child. It then finds the corresponding recipe in its own recipes array and updates the favorite property. This demonstrates how the parent keeps its data in sync with changes originating from its children. See other communication patterns, brief overview. While at input and at output, handle the vast majority of direct parent-child and child-parent communication, there are other patterns for more complex scenarios. 1. Local variables, and at viewChild, / at viewChildren, parent accessing child. Concept allows a parent component to directly access methods or properties of a child component instances embedded in its view. Usage conceptual. In the parent's template, give the child component a local template variable, apptimer mytimer apptimer. In the parent's TypeScript, use at viewChild to get a reference to that child. At viewChild mytimer, timer component, the parent can then call methods on the child directly. This timer component start timer. When to use. Use sparingly, mainly for specific direct actions where the child isn't just emitting an event. For simple data sharing, at input is preferred. Over-reliance can lead to tightly coupled components. 2. Services for unrelated components and global state management. Concept. Services are singletons, meaning only one instance exists, that provide functionality or data that is shared across multiple components, even if those components are not directly related, e.g., siblings or components in entirely different parts of the application tree. They are typically used for fetching data from a backend API, sharing application-wide configuration, managing global application state like user authentication status or a shopping cart. How it works, conceptual. Create an Angular service, e.g., recipe service. Inject the service into any component that needs its functionality or data. Components interact with the shared data or methods provided by the service. Analogy. A centralized news agency that distributes information to various reporters, components, who aren't directly talking to each other. When to use. When components are far apart in the component tree, or when you need a single source of truth for certain data. We will cover services in detail in a later chapter. 3. Event bus, deprecated for services. Historically, an event bus, using a shared subject or event emitter within a service, was sometimes used for unrelated component communication. However, this pattern is often discouraged in modern Angular in favor of more explicit state management, like reactive programming with RxJS, often within services, due to potential complexity and debugging difficulties. Common pitfalls/troubleshooting, Chapter 4. Modifying at input. Properties directly in the child. Problem. If a child component receives an object or array via at input, and then directly modifies that object array in the child's code, it will modify the same object in the parent component. This can lead to unexpected side effects because the parent isn't explicitly notified of the change, and it violates the unidirectional data flow principle. Solution. For primitive types, string, number, boolean, direct modification is fine as they are passed by value. For objects or arrays, if the child needs to make permanent changes to the data it received, it should typically emit an event to the parent with the new or updated data, allowing the parent to decide how to update its own data. Or, if the child only needs a local copy to modify without affecting the parent, make a deep copy of the input data, e.g., this my array equals ... this input array. Forgetting event emitters emit method. Problem. Declaring an at output, but not actually calling this my event emit data when the event occurs. Solution. Always remember to explicitly call emit when you want your output event to fire. Naming conventions for inputs outputs. Best practice. Inputs are usually named like properties, e.g., recipe title. Outputs are typically named after the event they represent, often ending with changed or event, e.g., favorite status changed, item selected. Avoid prefixing outputs with on, e.g., on favorite status changed, as this is typically reserved for event handlers in the component's own asterisk template. Overuse of @viewChild. Problem. Reaching into a child component via @viewChild for every type of interaction. This creates tight coupling. Solution. Favor at input for parent-to-child data flow and at output /event emitter for child-to-parent events. Use @viewChild only when absolutely necessary, for example, to directly call a child method that performs a visual action or to access a specific DOM element. Further reading/resources, Chapter 4. Angular documentation on component interaction. Angular.io/guide/component-interaction. Angular at input and at output, decorators. Angular.io/API/core/input and Angular.io/API/core/output. Angular event emitter. Angular.io/API/core/event emitter. Understanding component communication is crucial for building any application beyond the most trivial. Mastering at input for passing data down and at output. With event emitter for passing events, up will enable you to create well-structured, maintainable, and interactive Angular applications. In the next chapter, we will delve into Angular's routing system, which allows users to navigate between different pages or views within your single-page application. Chapter 5. Angular routing. Navigating your single-page application. In the previous chapters, we've learned how to build components and how they communicate. However, a typical application needs more than just a single view. Users expect to navigate between different sections, view details, open forms, and return to lists. In a traditional multi-page application, this means loading entirely new HTML documents. In a single-page application, SPA like Angular, navigation happens dynamically without full-page reloads, providing a smooth user experience. This is where the Angular router comes in. This chapter will guide you through setting up and using the Angular router to define navigation paths, display different components based on the URL, and pass data through routes. A. The concept of routing in SPAs. Traditional web versus SPAs. In the traditional web, clicking a link or submitting a form would send a request to a server, which would then deliver a completely new HTML page. The browser would then discard the old page and render the new one. This is why you'd see a flash or a brief blank screen during navigation. In SPA, the browser loads a single index.html file initially. All subsequent page changes are handled by JavaScript. The Angular router listens to changes in the browser's URL without a full page refresh, maps those URLs to specific components, and then dynamically swaps out the components in the designated area of your application. The URL still changes, which is great for bookmarking and browser history, but the underlying page never reloads. Why use a router? User experience provides a seamless desktop application-like feel. State management helps manage the application's state by allowing specific URLs to represent specific views or data. Bookmarkability. Users can bookmark specific pages within your SPA. Deep linking. You can share a URL that takes a user directly to a specific view within your application. Modularity keeps navigation logic organized and separate from core business logic. B. Setting up the Angular router. When you generated your application using ng-new-my-app routing, the Angular CLI automatically set up the basic routing configuration for you. Let's see what that includes. 1. App routing module. Angular applications use feature modules to organize code. The router configuration typically resides in a dedicated routing module, often App Routing Module TS for the main application routes, or feature-specific routing modules for lazy-loaded features, which we'll discuss later. Open your src/app/app routing module TS file. You'll likely see something like this simplified. Import ng module from @Angular core. Import router module routes from @Angular router. Import the components you want to route to. Import recipe list component from recipe list recipe-list.component. Import recipe detail component from recipe detail-detail.component. Import about component from about.component, assuming you create this. Const routes equals. Define your routes here. Path redirect to recipes path match. Full default route. Path recipes component recipe list component. Path recipes/id component recipe detail component. Paths about component. Path redirect to recipes wildcard route for 404 or redirect. Add ng module. Imports router module for route routes. Exports router module. Export class app routing module. Router module for route routes. This method registers the routes for the route application. The routes array is where you define your routing rules. Exports router module. This makes the router module available to other modules that import app routing module, namely app module. 2. Router outlet. This special directive is Angular's placeholder where routed components should be displayed. You place it in your main application components template app.component.html. src/app/app.component.html. Header, nav, a router link equals /recipes/a. A router link equals /about us a. Nav, header, main, router outlet. Components mapped to routes will be rendered here. Main, footer, p and copy, 2023, Angular recipe book p. Footer, when the URL matches a route, the corresponding component is rendered inside the router outlet. When the URL changes, the old component is destroyed and the new one is created. 3. Router link. Instead of using standard href attributes for navigation, Angular provides the router link directive. This directive prevents the browser from performing a full page reload and instead tells the Angular router to handle the navigation internally. Syntax: a router link equals /pathlink text a, or a router link equals /pathlink text a without for simple static paths. See defining your routes. The core of routing is the routes array, which is an array of route objects. Each route object defines a mapping between a URL path and a component. Basic route structure. A basic route object has two main properties: path, a string representing the URL path segment; component, the component to load when this path is active; const routes, routes equals; path, recipes component, recipe list component; paths, about component, about component. Redirecting routes, redirect to path match. Default route, *, you often want to redirect users from the route path to a default view, e.g., a recipes list. Path, redirect to, recipes, path match, full. Path match, full, this is critical. It means match the URL path exactly. Without it, an empty path would match every URL that starts with an empty string, which is all of them, leading to unexpected behavior. Path match, full ensures only matches. Wildcard route, 404 not found. Use a wildcard route to handle any URL that doesn't match a defined path. This is typically used for a 404 page not found component or to redirect to a main page. Paths component, not found component. Place this last in your routes array, as routes are matched from top to bottom. Passing data through routes. Applications often need to display details about a specific item. For example, clicking on a recipe item in a list should take you to a detailed view of that specific recipe. The router allows you to pass data in a few ways. 1. Route parameters. Concept. This is the most common way to pass single pieces of data, like an item's ID, to a routed component. The parameter becomes part of the URL itself. Defining in route, use a colon followed by the parameter name in the path. Path, recipes/ID component, recipe detail component. This route will match URLs like recipes1, recipes spaghetti carbonara, etc. The id part becomes a route parameter. Accessing in component. In the recipe detail component, you inject the activated route service to get the route parameters. You'll typically do this in the ng on init lifecycle hook. Import component on init from @Angular core. Import activated route param map from @Angular router. Import param map. Import recipe service from recipe service. Assume you have a service for data. @Component. Selector, app recipe detail. Template URL, recipe-detail.component.html. Style URLs, /recipe-detail.component.css. Export class, recipe detail component implements on init. Recipeid, string null equals null, recipe any. Property to hold the fetched recipe details. Constructor, private route. Activated route / private recipe service, recipe service. ng on init, void. Using snapshot, good for routes that don't change parameters. This recipeid equals this route snapshot param map get ID. Console log recipe ID from snapshot. This recipeid. This recipe equals this recipe service get recipe by ID, this recipe ID. Fetch data. Using observable. Essential if the component can be reused with different IDs. E.g., navigating from recipes 1 to recipes 2 without leaving the component. This route param map subscribe, params. Param map equals. This recipeid equals params get ID. Console log recipe ID from observable, this recipeid. This recipe equals this recipe service get recipe by ID, this recipe ID. Fetch data again if ID changes. Snapshot provides immediate access to the current route parameters. Useful when you know the component will be created once and then destroyed if the route changes, e.g., navigating from recipes 1 to about. Param map, observable. Recommended for scenarios where the same component might be reused for different parameter values, e.g., navigating from recipes 1 to recipes 2 while staying on the recipe detail component. Observables respond to changes over time. 2 query parameters, concept. Data appended to the URL after a question mark, e.g., category equals Italian and sort equals popularity. They are optional and can be used for filtering, searching, or pagination. Navigation. Use query params object with router link. A router link equals /recipes, query params equals category. Desserts page. 2 dessert recipes. This would generate a URL like /recipes, category equals desserts, and page equals 2. Accessing in component. Similar to root parameters, but using query param map from activated root. Import activated root param map from @Angular router. Constructor private root, activated root. ng on init, void. This route query param map subscribe, params. Param map equals const category equals params get category. Const page equals params get page. Console log category, category page, page. 3-state object advanced, concept. You can pass complex JavaScript objects through the router's state. But this data is only available when navigating to asterisk the root and does not persist in the URL. So it's not visible and cannot be bookmarked or reloaded. It's often used when navigating imperatively via code. Navigation. This router navigates /details. State. Recipe data, some object. Accessing. History state recipe data access via window history object. This is less Angular idiomatic, and services are generally preferred for passing complex state. Programmatic navigation. While router link is great for declarative navigation in templates, you often need to navigate programmatically based on user actions or application logic, e.g., after submitting a form successfully. This is done by injecting the router service. Injecting the router service. Import router from @Angular router. Constructor private router, router. Navigating to a simple path. This router navigate /recipes. Navigating with a root parameter. This router navigate /recipes, recipeid. Navigating with query parameters. This router navigate /recipes, query params. Category, Italian. Navigating with relative paths. If you're already at recipes and want to navigate to a child root like recipes new recipe, you can use relative to. This router navigate new recipe, relative to this root, where this root is the injected activated root. Child roots, nested routing. Often, sections of your application have their own subsections. For example, a user dashboard might have subsections for profile, settings, and orders. This can be modeled with child roots. Concept. A component can also have its own router outlet to display child components. This creates a nested routing structure. Defining in roots, use the children property in a root definition. Const user roots. Roots equals path user dashboard. Component user dashboard component. This component has its own router outlet. Children path redirect to profile path match full. Path profile component. User profile component. Path settings component. User settings component. Path orders component. User orders component. Parent template for nested roots. The user dashboard components template would contain its own router outlet. User-dashboard.component HTML. Nav. A router link equals profile my profile a note. Relative path. A router link equals settings/a. A router link equals orders my orders a. Nav. Router outlet, child roots render here. Navigation to user dashboard profile would load user dashboard component, and then user profile component would be rendered inside its router outlet. Notice the router link for child roots, profile instead of user dashboard profile. The router understands that these are relative to the current root. Common pitfalls /troubleshooting, Chapter 5. Incorrect path match. Problem for getting path match. Full for the empty path redirection route. This can lead to the redirect applying to all URLs or unexpected routing behavior. Solution. Always use path redirect to your default path match. Full. Route order matters. Problem. Placing a wildcard route before specific routes. The wildcard will match everything, making subsequent routes unreachable. Solution. Define your specific routes first, followed by parameterized routes, and place the wildcard route last in the routes array. Forgetting router outlet. Problem. No component loads or components load incorrectly if router outlet is missing from the template of the component that acts as the container. Solution. Ensure router outlet is present where you want rooted components to appear. Remember that parent components for child roots also need their own router outlet. Debugging root issues. Solution. Use the Angular Dev Tools browser extension. It can show you the active root snapshot, parameters, and other routing-related information, which is invaluable for debugging complex routing scenarios. You can also temporarily add console log statements in the ng on init methods of your components to see which ones are being activated. Further reading / resources, Chapter 5. Angular Routing and Navigation Guide. Angular.io/guide/router. Router Module and Routes API. Angular.io/API/router/router module and Angular.io/API/router/routes. Activated routes. Angular.io/API/router/activated route. Router service. Angular.io/API/router/router. Mastering the Angular router is crucial for building single-page applications that feel responsive, structured, and user-friendly. You now know how to define paths, use router outlet to display components, pass data via route and query parameters, and navigate programmatically. In the next chapter, we'll shift our focus to data management, specifically how to interact with external services, like a backend API, to fetch and send data. Chapter 6. Services and HTTP communication, connecting to the backend. So far, we've focused on the front end of our Angular application. Building components, structuring templates, communicating between parent and child components, and handling navigation. But a truly dynamic web application needs to interact with the outside world. This often means fetching data from a server, sending user input to a database, or integrating with external APIs. This is where Angular services and HTTP communication come into play. This chapter will teach you about services as a core concept for organizing reusable logic and data, and how to use Angular's built-in HTTP client to make network requests to a backend or external API. Angular services, the workhorses of your application. What is a service? In Angular, a service is a class designed to be instantiated once and reused in various parts of the application. Services typically encapsulate common functionalities or data that are not tied to a specific component's UI concerns. They are singletons, meaning there's generally only one instance of a given service available throughout your application. Think of services as specialized, independent experts, or utility providers. A component might be responsible for displaying a list of recipes, but it shouldn't be responsible for how those recipes are fetched from a database or where they're stored. That's a job for a service. Key characteristics of services: single responsibility. Services are designed to do one thing well, e.g., fetch recipes, manage user authentication, log messages. Reusability. Because they are independent of specific components, they can be easily injected and used by multiple components throughout your application. Separation of concerns. They help keep components lean and focused on their UI responsibilities, deferring data access, business logic, and utility functions to services. Dependency injection. Services are created and provided using Angular's powerful dependency injection (DI) system. This makes your application modular, testable, and maintainable. Creating a service, ng-generate service. You can create a service using the Angular CLI. ng-generate services recipe or ng-gs services recipe. This command will create two files: src/app/services/recipe service ds, src/app/services/recipe service spec ts. For testing, the recipe service ds file will look something like this. Import injectable from @Angular core @injectable. Provided in root. Export class recipe service. Constructor. Example service method. Get greeting string. Return hello from recipe service. @Injectable decorator. This decorator marks a class as one that Angular's dependency injector can provide. Essentially, it tells Angular, hey, this class can be injected as a dependency into other classes. Provided in root. This metadata option, introduced in Angular 6+, is the modern way to register a service with Angular's dependency injection system. Provided in Root makes the service a singleton that is available globally throughout your application. This is the most common use case for most services. Alternatively, you can provide a service at the module level or component level, though provided in. Root is usually preferred unless you have a specific reason to limit its scope. Using a service, dependency injection. To use a service in a component or another service, you simply declare it as a constructor parameter with its type. Angular's DI system automatically detects the type and provides an instance of that service. Import component on init from @Angular core. Import recipe service from services recipe service. Import the service. At component, selector app recipe list, template URL, recipe-list.component HTML, style URLs, recipe-list.component CSS. Export class recipe list component implements on init. Greeting string. Constructor private recipe service, inject the service. The service instance is now available as this recipe service. ng on init, void. This greeting equals this recipe service get greeting. B. HTTP communication. The HTTP client. The HTTP client is Angular's robust and modern way to make HTTP requests. Get, post, PUT, delete, etc. to communicate with web servers. It is built on the XML HTTP request interface, but provides a simplified API and leverages RxJS observables for handling asynchronous responses. 1. Setting up HTTP client. Before you can use HTTP client, you need to import its module into your application's root module, app module ts. src/app/app module ts. Import ng module from @Angular core. Import browser module from @Angular platform browser. Import HTTP client module from @Angular/common/HTTP. Import HTTP client module. Import app routing module from app routing module. Import app component from app.component. Other component imports. @ng module. Declarations. App component. Other components. Imports. Browser module. App routing module. HTTP client module. Add HTTP client module to imports. Providers. Bootstrap app component. Export class app module. Once HTTP client module is imported, you can inject HTTP client into any service or component. 2. Making GET requests, fetching data. The most common HTTP operation is GET, used to retrieve data from a server. We'll typically encapsulate this in a service. Let's assume we have a simple JSON server running at http localhost :3000/recipes that returns a list of recipes. src/app/services/recipe service ds. Import injectable from @Angular core. Import HTTP client from @Angular/common/HTTP. Import HTTP client. Import observable from RxJS. Import observable. Define an interface for our recipe structure for better type checking. Interface recipe. id number title, string image URL, string favorite boolean. Add other properties as needed. Add injectable. Provided in root. Export class recipe service. Private API URL equals http localhost :3000/recipes. Our backend API URL. Constructor private HTTP. HTTP client. Inject HTTP client. Method to get all recipes. Get recipes. Observable recipe. HTTP client methods return an observable. Return this HTTP get recipe. Method to get a single recipe by ID. Get recipe by ID number. Observable recipe. Return this HTTP get recipe. $this API URL/$ID. RxJS observable. HTTP client methods return an observable from the RxJS library. Observables are powerful for handling asynchronous operations and streams of data. When you subscribe to an observable, you tell it you are interested in its data. Only then will the HTTP request actually be made. Type safety recipe. We use TypeScript generics recipe with HTTP GET to tell Angular what type of data we expect to receive, providing strong type checking. 3. Consuming the data in a component. Now, in our recipe list component, we can use the recipe service to fetch recipes. src/app/recipe-list/recipe-list.component.ts. Import component on init from @Angular core. Import recipe service from services recipe service. Interface recipe. Make sure this interface is also imported or defined. id number title, string image URL, string favorite boolean. At component, selector app recipe list, template URL, recipe-list.component.html, style URLs, recipe-list.component.css. Export class recipe list component implements on init. Recipes. Recipe equals error message, string is loading, boolean equals true, for showing loading indicators. Constructor private recipe service, ng on init, void. This get recipes. Call the method to fetch recipes when the component initializes. Get recipes, void. This is loading equals true, set loading state. This recipe service get recipes, subscribe. Next, data equals. This recipes equals data. Assign fetch data to our recipes array. This is loading equals false, hide loading. Error equals. Console error fetching recipes, error. This error message equals failed to load recipes. Please try again later. This is loading equals false, hide loading. Complete equals. Console log, recipe fetching complete. Subscribe method. The subscribe method is crucial. It activates the observable and allows you to handle the next successful data, error, HTTP error, and complete observable finished notifications. Error handling. It's vital to implement error handling error callback to display user-friendly messages if the backend request fails. 4. Making post, PUT, and delete requests. Post, creating data. Used to send new data to the server, e.g., creating a new recipe. In recipe service. Add recipe, new recipe. Omit recipe, id, observable recipe. Return this HTTP post recipe. This API URL, new recipe. In a component, this recipe service add recipe, title, new pasta, image URL, favorite, false, subscribe. Recipe equals console log, recipe added, recipe. Error equals console error adding recipe, error. PUT, updating data, used to update an existing resource, e.g., changing a recipe's details. In recipe service, update recipe, observable recipe. Return this HTTP put recipe, $this API URL / $recipe ID, recipe. In a component, const updated recipe equals, this recipe 0, title. Spaghetti with meatballs, this recipe service update recipe updated recipe, subscribe. Recipe equals console log, recipe updated, recipe. Error equals console error updating recipe, error. Delete, removing data. Used to delete a resource. In recipe service. Delete recipe ID, number, observable void. A delete request might not return content, so use void. Return this .http delete a void, $this API URL / $ID. In a component, this .recipe service .delete recipe, recipe ID to delete, subscribe, equals console log, recipe deleted successfully. Error equals console error deleting recipe, errors. F5. HTTP request options, headers, params. The HTTP client methods, get, post, etc. can take an optional options object for more control. HTTP headers. Used for things like authentication tokens, content types, etc. Import HTTP headers from @angular/common/http. Const headers equals new HTTP headers. Contents type, application/JSON. Authorization, bearer YOURUTHTOKN. This HTTP get recipe subscribe. URL search parameters, HTTP params, for adding query parameters. Import HTTP params from @angular/common/http. Let params equals new HTTP params. Params equals params append category, Italian. Params equals params append sort. Popularity, this HTTP get recipe subscribe. See common pitfalls / troubleshooting, Chapter 6. Forgetting to subscribe. Problem, the HTTP client methods return observables. If you don't call subscribe, the HTTP request will never actually be sent. Solution: always call subscribe on the observable returned by HTTP client methods to trigger the request and handle the response. Unsubscribed observables memory leaks. Problem: if you subscribe to an observable that never completes, like long-lived streams, and don't unsubscribe, when the component is destroyed, it can lead to memory leaks. Solution: for HTTP client requests, this is generally not an issue because the observable completes automatically after emitting next or error. However, for other types of observables, especially from subjects or custom sources, you must clean up subscriptions in ng on destroy using subscription unsubscribe, or by using RxJS operators like take until. CORS errors, cross-origin resource sharing. Problem: if your Angular app running on localhost 4200 tries to make a request to a backend on a different domain or port, e.g., localhost 3000, the browser's security policy will block it by default unless the server explicitly allows it. You'll see errors like access to XML HTTP request at from origin has been blocked by CORS policy. Solution: CORS needs to be handled on the backend server. The backend must send appropriate access control allow origin headers in its responses. If you're building both front-end and backend, you'll need to configure your backend, e.g., Node.js with Express, Python with Flask, to allow requests from your Angular application's origin. JSON parsing errors. Problem: HTTP client automatically parses JSON responses. If the server returns malformed JSON or something that isn't JSON, like an HTML error page, parsing will fail. Solution: check your backend's response using Browser Developer Tools Network tab to ensure it's sending valid JSON. Ensure your content type headers are correct. D. Further reading /resources, Chapter 6. Angular Services Guide. Angular.io/guide/architecture-services. Angular HTTP Client Guide. Angular.io/guide/HTTP. RxJS Documentation. RxJS.dev. While complex, understanding the basics of observables is key for Angular development. A simple JSON server for testing. GitHub.com/typicode/JSON-server. Great for quickly setting up a fake REST API for development. By leveraging services and Angular's HTTP client, your application can now dynamically fetch and send data, truly becoming a full-fledged web application. This opens up endless possibilities for creating rich, data-driven user experiences. In the next chapter, we'll dive into forms, allowing users to input data and interact with your application in a structured way. Chapter 7, Angular Forms, User Input and Validation. In the previous chapter, we mastered how to talk to a backend server using Angular services and HTTP. Building on that, the next logical step is to allow users to input data into our application, to add new recipes, update their profiles, or search for ingredients. This is where Angular Forms come into play. Angular offers two powerful approaches to handling user input with forms: reactive forms and template-driven forms. Both allow you to build forms, handle user input, validate data, and display validation messages. This chapter will introduce you to both, but focus primarily on reactive forms, which provide greater flexibility and control, especially for complex scenarios. Introduction to Angular Forms. The need for forms. Forms are fundamental to almost every interactive web application. They are the primary way users provide information, from simple searches to complex multi-step registrations. Building robust forms involves capturing user input, text, numbers, selections, validating that input against rules, e.g., required fields, email format, displaying meaningful feedback to the user, e.g., this field is required, handling form submission and data processing. Two approaches. Angular provides two different APIs for building forms: template-driven forms. These forms rely heavily on directives placed directly in the template. They are generally simpler for very basic forms, but offer less control. Reactive forms. These forms define the form structure programmatically in the component's TypeScript class. They offer more predictability, scalability, and easier testing, making them the preferred choice for most complex or dynamic forms. While we'll touch upon template-driven forms, this chapter will delve deeper into reactive forms. Reactive forms, building forms programmatically. Reactive forms offer a model-driven approach, where the form's structure and behavior are defined explicitly in the component's TypeScript code. 1. Setting up reactive forms. Before you can use reactive forms, you need to import the reactive forms module into your application's app module, or the specific feature module, where you'll be using forms. src/app/app module ts. Import ng module from @Angular core. Import browser module from @Angular platform browser. Import HTTP client module from @Angular/common/HTTP. Import reactive forms module from @Angular forms. Import reactive forms module. Import app routing module from app routing module. Import app component from app.component. Other imports. @ng module. Declarations. App component. Imports. Browser module. App routing module. HTTP client module. Reactive forms module. Add reactive forms module to imports. Providers. Bootstrap app component. Export class app module. 2 core building blocks of reactive forms. Reactive forms are built upon 3 fundamental classes. Form control represents a single input field in a form. It manages the value and validation status of that input. Form group manages a collection of form control instances or other form groups into a single, cohesive form or a section of a form. It aggregates the values and validation status of its children. Form array manages an array of form control or form group instances. Useful for dynamic forms where you need to add or remove groups of fields, e.g., multiple ingredients in a recipe. 3. Creating a simple form, add recipe form. Let's create a form to add a new recipe with title, image URL, and servings fields. Component, add-recipe.component ts. Import component on init from @Angular core. Import form group, form control, validators from @Angular forms. Import form classes and validators. @Component, selector, app-add-recipe, template URL, add-recipe.component HTML, style URLs, /add-recipe.component CSS. Export class, add-recipe component implements on init. Add-recipe form. Form group, declare our form group. Constructor, ng on init, void. Initialize the form group with form controls. This add-recipe form equals new form group. Title, new form control, null, validators required. Null is initial value. Validators required is a validator. Image URL, new form control, null, validators required, validators pattern /HTTP, HTTPS, ///+$/. Multiple validators. Servings, new form control, null, validators required, validators min, 1, validators max, 20. On submit, void. If this add-recipe form valid, check if the form is valid. Console log form submitted, this add-recipe form value. In a real app, you would send this data to a service backend. This recipe service add recipe, this add recipe form value. Subscribe, this add recipe form reset. Reset the form after submission. Else, console log form is invalid. Optionally, mark all controls as touched to display validation messages. This add recipe form mark all as touched. We import form group, form control, and validators. Add recipe form is initialized in ng on init. Each form control typically takes 2 arguments, an initial value, here, null, and an array of validators. Validators required, validators pattern, validators min, validators max are built-in validators. The onSubmit method checks this add-recipe form valid before processing. Template add-recipe.component HTML. Div class equals add-recipe container. Add new recipe h2. Form group equals add-recipe form. ng submit equals onSubmit. Div class equals form group. Label for equals title, recipe title label. Input type equals text, ID equals title, class equals form control name equals title. Validation messages. Div ng if equals add recipe form get title. Invalid and an add recipe form get title. Touched class equals alert danger. Span ng if equals add recipe form, get title, errors. Required title is required span. Div class equals form group. Label for equals image URL label. Input type equals text, ID equals image URL, class equals form control name equals image URL. Div ng if equals add recipe form get, image URL. Invalid and an add recipe form get, image URL. Touched, class equals alert danger. Span ng if equals add recipe form get, image URL, errors. Required image URL is required span. Span ng if equals add recipe form, get image URL, errors. Pattern please enter a valid URL span. Div class equals form group. Label for equals servings label. Input type equals number, ID equals servings. Class equals form control name equals servings. Div ng if equals add recipe form get servings. Invalid and an add recipe form get servings. Touched, class equals alert danger. Span ng if equals add recipe form, get servings. Errors. Required servings is required span. Span ng if equals add recipe form get servings. Errors. Minimum servings is 1 span. Span ng if equals add recipe form get servings. Errors. Maximum servings is 20 span. Div button type equals submit, disabled equals. Add recipe form valid, class equals btn primary, submit recipe button. Div form group equals add recipe form. Links the HTML form element to the form group instance in the component. Form control name equals name. Links individual input fields to their corresponding form control instance within the form group. Ng if control name, invalid and end control name. Touched. This common pattern displays validation messages only if the control is invalid and the user has interacted with it, touched it. This prevents showing errors before the user has a chance to type. Control name, errors, validator name, accesses specific validation errors for a control. Disabled equals, add recipe form valid. Disables the submit button until the entire form is valid. For form builder, more convenient form group form array creation. For more complex forms with many controls, Form Builder provides a more concise and readable way to create form group and form array instances. Import Form Builder, Form Group, Form Control, Validators, Form Array from @Angular Forms. Import Form Builder. Inside your component. Constructor, private FB. Form Builder, inject Form Builder. Ng on init, void. This addrecipe form equals this FB group. Title, null, validators required, shorthand, value, validators. Image URL, null, validators required, validators pattern, /http https, /bic//plus $/. Servings, null, validators required, validators min 1, validators max 20. Ingredients, this FB array, example of form array for dynamic ingredients. This FB group, name, null, validators required. Amount, null, validators required, validators min, 0.1. Add ingredient, void. This add recipe form get ingredients as form array. Push this FB group. Name, null, validators required. Amount, null, validators required, validators min, 0.1. Notice FB group and FB array as shorthand for new form group and new form array. Null, validators required is the shorthand for new form control, null, validators required. We added an example of a form array for ingredients, where each ingredient is itself a form group with name and amount. See template-driven forms, brief overview. Template-driven forms rely heavily on directives like ng model and ng form directly in the HTML template. Angular infers the form structure from the template. 1. Setting up template-driven forms, you need to import Forms module into your app module. src/app/app module ts. Import Forms module from @Angular Forms. Import Forms module. @ng module. Imports. Forms module. Add Forms module to import. Export class app module. 2. Simple example. Form recipe form ng form. ng submit equals on submit recipe form. Div class equals form group. Label for equals title recipe title label. Input type equals text, ID equals title, name equals title. ng model equals recipe title, required title equals ng model. Div ng if equals title dot invalid and end title touched. Class equals alert danger. Span ng if equals title errors. Required title is required span. Div button type equals submit disabled equals recipe form valid submit / button. Form recipe form ng form exports the ng form directive instance into a local template variable recipe form. This directive manages the overall form. Name equals title, necessary for ng model to work. ng model equals recipe title, provides two-way data binding. It also implicitly creates a form control behind the scenes. Required, standard HTML5 validation attribute used by ng model to set the validation status. Title equals ng model. Exports the ng model directive instance, which represents the form control, into a local template variable title, allowing us to check its invalid and errors properties. When to use which. Reactive forms. Recommended for most cases, especially if your forms are complex, dynamic, or if you need custom validators, testing, or complex data flow logic. They provide more robust, predictable, and maintainable solutions. Template-driven forms can be useful for very simple forms, e.g., a single contact form with static structures and minimal validation, where you prefer to define most of the form directly in the template. Form validation, ensuring data integrity. We've already seen examples of built-in validators, but let's summarize and clarify. Built-in validators class, validators required, field must not be empty. Validators email, value must be a valid email format. Validators min length num, value must have at least num characters. Validators max length num, value must have at most num characters. Validators min num. For numbers, value must be at least num. Validators max num, for numbers, value must be at most num. Validators pattern rejects, value must match the provided regular expression. Custom validators. For validation rules not covered by built-in validators, you can create custom validator functions. These functions take a form control or form group as an argument and return a validation error object if invalid or null if valid. Example, forbidden name validator, conceptual. Imagine a validator that checks if a recipe title is on a list of forbidden words. Custom validator function outside the component, e.g., in a separate file. Import abstract control, validation errors from @Angular forms. Export function forbidden name validator control. Abstract control, validation errors null. Const forbidden names badword1, badword2, example forbidden names. Const value equals control value as string. If value and then forbidden names dot includes, value to lowercase. Return forbidden name. Value, control value, return an error object. Return null if valid. Usage in your component. Title, new form control, null, validators required, forbidden name validator. This would then be checked in the template with add recipe form get title, errors, forbidden name. Asynchronous validators for server-side validation. For validation that requires a server request, e.g., checking if a username is already taken, you use asynchronous validators. These return an observable or promise that eventually resolves to validation errors or null. These are more advanced and will be covered in more in-depth form topics. Common pitfalls / troubleshooting, Chapter 7. Forgetting to import modules, problem. Cannot bind to form group since it isn't a known property. Or can't bind to ng model since it isn't a known property. Solution. Ensure you've imported reactive forms module for reactive forms or forms module for template-driven forms into your app module or the specific feature module where your form component resides. Mismatch form control name and form control key. Problem, typo in form control name in the HTML form control name equals title, while the form group key is title. Solution. Double-check that the string passed to form control name exactly matches the key used when defining the form control in your form group in the component. Not checking form valid before submission. Problem. Your onSubmit method processes potentially invalid data. Solution. Always include "if this your form valid" at the beginning of your submission handler. Validation messages shown too early. Problem. Users see this field is required as soon as the form loads. Solution. Use the touched or dirty properties of the form control or form group, along with invalid in your NG if conditions for validation messages, e.g., NG if equals control.invalid and control dirty control touched. Touched means the user has blurred out of the field. Dirty means the user has changed the value. F. Further reading /resources, Chapter 7. Angular Reactive Forms Guide. Angular.io/guide/reactive-forms. Highly recommended first stop. Angular Template-Driven Forms Guide. Angular.io/guide/template-driven-forms. Angular Form Validation. Angular.io/guide/form-validation. Form Group, Form Control, Form Array, Form Builder API. Angular.io/API/forms/form group, etc. Built-in validators. Angular.io/API/forms/validators. Forms are a deep and critical topic in web development. By mastering Angular's reactive forms, you gain a robust and flexible way to handle user input, validate data, and provide a polished user experience. This empowers you to build even more interactive and data-driven applications. In the next chapter, we'll shift gears slightly to look at dependency injection more broadly and unit testing, ensuring our application remains maintainable and reliable as it grows. Chapter 8, Dependency Injection and Testing Angular Applications. We've covered many core aspects of building an Angular application: components, templates, data binding, routing, services, and forms. Now, let's dive into two crucial concepts that underpin Angular's architecture and enable robust, maintainable applications: dependency injection, DI, and testing. Dependency injection is a fundamental design pattern that Angular heavily relies on, and understanding it will deepen your grasp of how the framework works. Testing, on the other hand, ensures that your application behaves as expected, catches bugs early, and facilitates confident refactoring and scaling. Demystifying dependency injection, DI. You've already encountered dependency injection several times without perhaps fully realizing it. For example, when we injected HTTP client into our recipe service or activated route and router into our components, we were using Angular's DI system. What is dependency injection? Dependency injection is a design pattern where a class receives its dependencies, the objects it needs to perform its function, from an external source, rather than creating them itself. Without DI, traditional code. Imagine a recipe component that needs a recipe service to fetch data. A traditional approach might involve the recipe component directly creating an instance of recipe service inside its constructor. Class recipe component, private recipe service, constructor. This recipe service equals new recipe service. Component creates its own dependency. This approach quickly becomes problematic. Tight coupling. Recipe component is tightly coupled to recipe service. If recipe service's constructor changes, e.g., it now needs a database connection, recipe component must also change. Difficult testing. To test recipe component, you'd always have to create a real recipe service and potentially a real database connection, making tests slow and complex. Reduced reusability. The specific recipe service instance is locked into this component. With DI Angular's way, in an Angular application, the recipe component declares its need for recipe service as a parameter in its constructor. Angular's DI system then provides an instance of recipe service when it creates recipe component. Import recipe service from recipe service, class recipe component. Constructor, private recipe service. Recipe service, component declares its dependency. Angular's DI provides the instance. This approach offers significant advantages. Loose coupling. Recipe component doesn't care how it gets a recipe service instance, only that it has one that fulfills the recipe service interface. Easier testing. During testing, you can easily provide a mock or fake recipe service that behaves reliably without connecting to a real backend. Increased reusability. The recipe service can be easily shared across multiple components without each one having to create its own instance. Configuration flexibility. You can configure Angular's injector to provide different implementations of a service based on the environment, e.g., a mock service for development, a real service for production. How Angular's DI system works. Angular's DI system relies on injectors and providers. Injector. An injector is an object that can create dependencies and inject them where needed. Angular creates a hierarchy of injectors, a root injector for the entire application, and then child injectors for modules and components. Provider. A provider is a recipe that describes how to obtain an instance of a dependency. When you specify provided in, root in at injectable, you're telling Angular to provide this service globally. Provider types beyond provided in. Root. While provided in, root is the most common, you can also define providers in, module providers, by adding a service to the providers array in an @ng module. This makes the service available to all components and services declared within that module. @ng module. A providers recipe service provides recipe service to this module. Export class app module. Component providers. By adding a service to the providers array in an @component decorator. This creates a new instance of the service for each instance of that component and its children. This is typically used when you need a unique, isolated instance of a service for a specific component. @component. Selector. App recipe details. Template URL. Recipe-details.component.html. Providers. Recipe service. Provides a new instance of recipe service for this component instance. Export class recipe details component. Injection tokens. Sometimes what you want to inject isn't a class. For example, you might want to inject a configuration object or a simple string. For these cases, you use an injection token. An injection token is a unique identifier that you can associate with a provider. app.config.ts or similar. Import injection token from @Angular core. Export const appconfig equals new injection token string app.config. App module ts. @ng module. Providers. Provide appconfig use value. Development mode. Provide a string value. Export class app module. In a component or service that needs it. Import inject from @Angular core. Import appconfig from app.config. Constructor @inject appconfig private config string console log appconfig this .config. Be testing Angular applications. Testing is a critical part of developing robust and reliable software. Angular provides excellent tools and conventions for testing your applications, primarily using the Karma test runner and the Jasmine testing framework. Types of tests. Unit tests. Focus on testing individual, isolated units of code, e.g., a single component without its template, a service, a pipe, a directive, to ensure they work as expected. These are the most common and fastest running tests. Integration tests. Verify that different units or modules work together correctly. For example, testing how a component interacts with a service. End-to-end, E2E tests. Simulate user interaction with the entire application running in a real browser. These are slower but ensure the overall user journey works. Note, as of Angular 16, Protractor, the default E2E testing framework has been deprecated. Most new projects use Cypress or Playwright for E2E testing. This book primarily focuses on unit and integration testing with Jasmine Karma. Running tests. The Angular CLI makes running tests easy. ng-test runs all unit and integration tests configured in your project. It opens a browser window where the tests execute and automatically reruns tests when you save changes to your files. ng-test no-watch runs tests once and exits. Good for CI/CD pipelines. ng-test include equals src/app/recipe-list/recipe-list.component-spec-ts. Runs tests only for a specific file. Anatomy of a unit test file. When you generate components or services with the CLI, it automatically creates a spec-ts file alongside them, e.g., recipe-list.component-spec-ts, recipe service spec-ts. These files contain test suites. Describe defines a test suite, a group of related tests. It, or fit, defines a single test specification, individual test case. Fit temporarily runs only that specific test, useful for debugging. Expect, used for assertions to check if a value meets a certain condition. Before each, a function that runs before each it, block within a describe, block. Useful for setting up test data or environment. Testing a service, unit test. Services are typically plain TypeScript classes, making them very easy to unit test. We just need to create an instance and call its methods. src/app/services/recipe-service-spec-ts. Import testbed from @Angular core testing. Import a HTTP client testing module, HTTP testing controller, from @Angular/common/HTTP/testing. For HTTP testing, import recipe service from recipe service, describe recipe service, equals, let service, recipe service, let HTTP mock, HTTP testing controller. For mocking HTTP requests, before each equals, testbed.configure testing module. Imports HTTP client testing module, import for HTTP client testing. Providers, recipe service, the service we want to test. Service equals testbed.inject, recipe service. Get an instance of our service. HTTP mock equals testbed.inject, HTTP testing controller. Get the mock HTTP controller. After each equals, after each test, verify that no unmatched requests are outstanding. HTTP mock verify. It should be created, equals. Expect service to be truthy, check if the service instance was created. It should retrieve recipes from the API via get, equals. Const dummy recipes. id1 title. Test recipe 1, image URL, favorite false. id2 title. Test recipe 2, image URL, favorite true. Service get recipes, subscribe recipes equals. Expect recipes length to be 2. Expect recipes to equal dummy recipes. Set up the mock HTTP request expectation. Const rec equals HTTP mock expect 1, HTTP localhost 3000/recipes. Expect one request to this URL. Expect rec request method to be get. Expect it to be a GET request. Rec flush dummy recipes. Provide the dummy data as the response. A testbed, Angular's testing utility. Configure testing module sets up a testing environment similar to an Angular module. HTTP client testing module and HTTP testing controller. Essential for testing services that make HTTP requests. HTTP testing controller allows you to mock HTTP responses so your tests don't actually hit a real backend. Flush sends the mock response. Testing a component, unit test. Testing components is more involved as they involve templates, data binding, and interactions. The testbed helps create and interact with a component in a testing environment. src/app/recipe-list/recipe-list.component-spec-ts. Import component fixture, testbed, from @Angular core testing. Import, provide HTTP client, from @Angular/common/HTTP. For providing a real HTTP client dependency. Import, provide HTTP client testing, from @Angular/common/HTTP/testing. For mocking HTTP requests. Import HTTP testing controller, from @Angular/common/HTTP/testing. Import NOERRORSSEHTMA from @Angular core. For ignoring unknown elements attributes. Import recipe list component from recipe-list.component. Import recipe service from services recipe service. We need to mock this. Describe recipe list component equals. Let component recipe list component. Let fixture component fixture recipe list component. Let mock recipe service any. We'll create a mock version of the service. Let HTTP mock HTTP testing controller before each async equals. Create a mock recipe service. Mock recipe service equals Jasmine create spy obj recipe service. Get recipes. Make the mock method observable. Mock recipe service get recipes and return value. New promise resolve equals resolve. Default empty array for testing. Await testbed.configure testing module. Imports / no special modules needed for basic component testing. Declarations, recipe list component. Providers, provide, recipe service use value. Mock recipe service, provide the mock service. Provide HTTP client, provide the real HTTP client. Provide HTTP client testing. Provide HTTP testing utilities. Schemas, no error schema. Ignore unknown HTML elements or attributes in the template. Useful when testing a component that uses other custom components. In a real integration test, you would declare those components too. Compile components. Compile components if using external template styles. Fixture equals test bed create component, recipe list component. Component equals fixture.component instance. Get the component instance. HTTP mock equals testbed.inject HTTP testing controller. Get the mock HTTP controller. It should create equals expect component to be truthy. It should call get recipes on ng on init equals fixture.detect changes triggers ng on init. HTTP mock expect 1 HTTP localhost :3000/recipes. Expect the HTTP call when get recipes is called. Flush. Fulfill the request. No, this isn't correct here. The mock recipe service is what gets called, not the actual HTTP in this setup. Expect mock recipe service get recipes to have been called ×1. It should display recipes after fetching, async, equals, const dummy recipes, id1 title, pasta image URL, favorite false, id2 title, salad image URL, favorite false. To ensure mock service, returns observable date. Mock recipe service get recipes and return value. New promise, resolve equals resolve dummy recipes. Fixture.detect changes, triggers ng on init, which calls get recipes. Wait for asynchronous operations to complete. Await fixture when stable, waits for all pending promises async tasks. Fixture.detect changes. Update the view after data is present. Const compiled equals fixture native element as HTML element. Const recipe titles equals compiled query selector, all, recipe title. Assuming a class in template. Expect recipe titles length to be 2, expect recipe titles 0, text content to contain pasta, expect recipe titles 1, text content to contain salad. A component fixture provides access to the component instance, its host element, native element, and methods to control change detection, detect changes. Jasmine creates by obj. A Jasmine utility to create a mock object with predefined methods that spy on calls. Fixture.detect changes tells Angular to run change detection. This is crucial for updating the component's template. NOERRORSSCHEMA. Useful for unit tests where you don't care about nested components. In integration tests, where you test how components work together, you would usually declare nested components in declarations or import modules that provide them. See Common Pitfalls / Troubleshooting, Chapter 8. Circular Dependencies. Problem. If service A depends on service B and service B depends on service A, you'll create a circular dependency that breaks DI and causes errors. Solution, refactor your code. Usually, this means one service should have primary responsibility and the other should either call its methods to get data or pass data via an observable. Missing providers. Problem. No provider for service X? Error. This means Angular's injector doesn't know how to create an instance of the service you're trying to inject. Solution. Ensure the service is properly provided either via provided in, root inits at injectable, decorator, or by listing it in the provider's array of the appropriate ng module or at component. Testing asynchronous code. Problem. Tests failing because asynchronous operations, like HTTP calls or promises, haven't completed before assertions run. Solution. Use async await with fixture when stable for promise-based operations or fake async with tick for more granular control over timers and microtasks. For observables, subscribe and done, callback or RxJS test scheduler can be used. Too much setup in before each. Problem. Your before each block becomes very long and complex, making tests difficult to read and maintain. Solution. Keep before each focused on the minimum setup required for the current test suite. Use helper functions, testbed utilities, or nested describe blocks to organize subsuites. D. Further reading/resources, Chapter 8, Angular Dependency Injection Guide. Angular.io/guide/dependency-injection. Angular Testing Guide. Angular.io/guide/testing. Jasmine Documentation. Jasmine.github.io. Karma Test Runner. Karma-runner.github.io. RxJS Testing. rxjs.dev/guide/testing. For more advanced RxJS testing. Dependency injection is the backbone of Angular, enabling its modularity, testability, and scalability. Coupled with robust testing, you can build applications that are not just functional, but also maintainable and easier to evolve over time. With these two pillars mastered, you're well on your way to becoming a proficient Angular developer. In the next chapter, we'll explore some advanced topics that will help you build even more performant and enterprise-ready Angular applications. Chapter 9, Advanced Topics, Performance, State Management, and Beyond. Congratulations! You've built a solid foundation in Angular, covering components, data binding, routing, services, forms, and the critical concepts of dependency injection and testing. You're now equipped to build functional and maintainable web applications. However, as applications grow in complexity and scale, additional considerations become vital. This chapter delves into several advanced topics that will help you build more performant, scalable, and sophisticated Angular applications. Performance optimization, state management, and a brief look at progressive web apps (PWAs) and server-side rendering (SSR). Performance optimization. Performance is crucial for user experience. A fast application feels responsive, engaging, and professional. Angular provides several built-in mechanisms and best practices to optimize performance. 1. Change detection strategy on push. Concept. Angular's change detection mechanism automatically updates the DOM when component data changes. By default, it runs frequently, checking every component from top to bottom whenever an event occurs, e.g., user interaction, HTTP response, set timeout. While efficient for small apps, this can become a bottleneck in large applications with many components. Solution: on-push strategy. By setting change detection strategy, on-push in your components at component decorator, you tell Angular to run change detection for that component and its children only when. And at input, properties reference changes for objects arrays or its value changes for primitives. An event originated from the component itself, e.g., a button click within its template. An observable it subscribes to emits a new value. You explicitly trigger change detection, this .changedetectorref.detect changes. Benefits. Reduces the number of checks Angular has to perform dramatically, leading to significant performance gains, especially in components that receive data via at input and don't manage complex internal state changes. Example: import component change detection strategy from @Angular core, @component. Selector, @myOptimized component. Template URL, my-optimized-component.component HTML. Change detection strategy, on push. Apply on push strategy. Export class, myOptimized component. Component logic. 2 lazy loading modules. Concept. By default, when your Angular application starts, all its modules and components are loaded, even those that aren't immediately needed by the user. This increases the initial bundle size and slows down the first load. Solution. Lazy loading loads parts of your application, modules, only when the user navigates to a route associated with that module. Benefits. Reduces the initial load time significantly, as the browser downloads only the necessary code chunks up front. Other chunks are downloaded as needed, on demand. How it works, conceptual. Instead of importing a feature module directly into app module, you configure a route in app routing module to load it lazily. App routing module TS. Const routes equals. Other routes. Path, recipes, when user navigates to recipes. Load children, equals import, /recipes module. Then m equals mRecipes module, load recipes module. This creates separate JavaScript bundles. When the user visits recipes, the recipes module TS bundle is downloaded and loaded. 3. Using the async pipe. Concept. When working with observables, especially with HTTP client requests, you often subscribe to them in TypeScript to get data and then display it. This requires manual subscription management and unsubscription to prevent memory leaks. Solution. The async pipe handles subscriptions and unsubscriptions automatically for observables and promises directly in the template. Benefits. Simplifies component code, reduces chances of memory leaks, and can indirectly contribute to performance by integrating well with on-push change detection. The component only re-renders when the observable emits. Example. Component TS. Import component from @Angular core. Import observable from RxJS. Import recipe service from recipe service @component/. Export class recipe list component. Recipes $observable recipe. Notice the convention for observables. Constructor private recipe service. Recipe service. This recipe's $equals this recipe service get recipes. Assign the observable. No need for ng on init, subscribe or unsubscribe. Component HTML. Div ng if equals recipes $async as recipes. Use async pipe. Div ng for equals let recipe of recipes. H3 recipe title H. Div asterisk 4 track by function with ng for. Concept. Asterisk when ng for renders a list and the data source changes, e.g., items are added, removed, or reordered. Angular by default re-renders all the DOM elements in the list that have changed. For large lists, this can be inefficient. Solution. Provide a track by function to ng for. This function tells Angular how to uniquely identify each item in the list. When the data changes, Angular can then optimize by only re-rendering elements that have actually changed identity, rather than recreating everything. Example. Component TS. Export class recipe list component. Track by recipe ID index, number recipe, number. Return recipe id. Assuming each recipe has a unique id. Component HTML. Div ng for equals let recipe of recipes. Track by recipe id. Recipe item content. Div b. State management. As applications grow, managing their data or state across many components, services, and asynchronous operations can become very complex. Where should data reside? How do components needing the same data stay synchronized? How do you reliably update that data? The problem: without a clear state management strategy, you can quickly fall into prop drilling, passing data through many layers of components via input, callback hell, complex chains of output, events, or inconsistent data across different parts of your UI. Solutions: service-based state management. For many applications, a well-structured service acting as a central data store is sufficient. Concept: a service holds the application state, e.g., an array of recipes, user authentication status, and exposes methods to modify that state. Components and other services subscribe to observables provided by this service to get updates. How it works conceptual. Recipe store service DS. Import injectable from @Angular core. Import behavior subject observable from RxJS. Import recipe from recipe model, assuming recipe interface. Add injectable provided in. Root. Export class recipe store service. Private recipes equals new behavior subject recipe. Holds current list of recipes. Read-only recipes $. Observable recipe equals this recipes as observable. Public observable. Constructor / private HTTP. HTTP client. Load initial data or fetch from backend here. This HTTP get recipe subscribe. Data equals this recipe's next data. Add recipe void. Const current recipes equals this recipe's get value. This recipe's next current recipe's recipe immutably update state. Other methods like update recipe, delete recipe, etc. Components would then inject recipe store service and directly use this recipe store recipes $async in their templates. Redux pattern libraries, ngrx, ngxs. For very large enterprise-level applications with complex state interactions, a more formal pattern like Redux can be beneficial. Concept: these libraries implement a unidirectional data flow pattern. State is held in a single, immutable store. Data can only be modified by dispatching actions, events describing what happened. A reducer function then takes the current state and an action and returns a new state. Selectors are used to query data from the store. Benefits: predictable state changes, easier debugging, time travel debugging, and a highly scalable architecture. Drawbacks: steeper learning curve, more boilerplate code. When to use: when service-based management becomes unwieldy, typically for applications with many shared pieces of state, complex user interactions, or very strict data consistency requirements. See Progressive Web Apps, PWAs. Concept: PWAs are web applications that bridge the gap between traditional websites and native mobile apps. They deliver an app-like experience, offline capabilities, push notifications, home screen icon, directly within a web browser, without requiring installation from an app store. Key PWA technologies: service workers, a JavaScript file that runs in the background, separate from the web page. It can intercept network requests, cache assets, and serve content offline. Web app manifest, a JSON file that describes the application, name, icons, start URL, display mode. HTTPS, required for security and for service workers to function. Angular CLI integration. Angular makes building PWAs relatively easy. The CLI can add PWA capabilities to an existing project. ng-add at angular/PWA. This command adds a service worker, a manifest file, and updates your project configuration to register them. Benefits: improved user engagement, fast, reliable, engaging, wider reach, works on any device with a browser, and easier deployment, no App Store approvals. D. Server-side rendering, SSR, with Angular Universal. Problem with SPAs: while SPAs provide a fantastic user experience after the initial load, they often have two drawbacks for the first load. Initial load time: the browser downloads and executes a lot of JavaScript before anything is rendered, leading to a blank screen. SEO, search engine optimization. Although modern search engines are better at crawling JavaScript, some still prefer content rendered on the server for better indexing and discovery. Solution: server-side rendering SSR, specifically using Angular Universal. Concept: Angular Universal allows you to run your Angular application on a server, e.g., using Node.js to generate static HTML pages for each route. When a user requests a URL, the server sends back a fully formed HTML page, which the browser can immediately display. Once the client-side Angular application downloads, it hydrates this static content, taking over and making it interactive. Benefits: faster first contentful paint, FCP. Users see content much faster, improving perceived performance. Improved SEO. Search engine crawlers get to see a fully rendered page, which can improve indexing. Better accessibility. Content is available sooner for screen readers and other assistive technologies. Setup: the Angular CLI also supports adding Universal. ng-add at Universal/Express Engine, or the equivalent for other server-side technologies. Considerations: adds complexity to your build process and requires server-side infrastructure. Common pitfalls/troubleshooting, Chapter 9. On-push and immutability. Problem: if you modify an object or array passed via at input. In place, when using on-push strategy, Angular won't detect the change, and your component might not update. Solution: always create new object references or array references when updating data. This my object equals this my object new prop, new value, or this my array equals this my array new item. This is called immutability. Lazy loading debugging. Problem: broken routes or missing components with lazy loading setup. Solution: check network requests in your browser's developer tools to ensure the lazy loaded bundle is actually being downloaded when you navigate to the route. Ensure the path in load children is correct and the module class name, mRecipes module, is accurate. SSR hydration issues. Problem: discrepancies between server-rendered HTML and client-side Angular rendering can lead to flicker or errors during hydration. Solution: ensure consistent data fetching on both server and client. Avoid direct DOM manipulation outside of Angular's rendering cycle. F. Further reading/resources, Chapter 9. Angular Performance Guide. Angular.io/guide/performance. Angular change detection. A fundamental concept often explored in depth in advanced articles covering Zone.js and change detection strategy. Angular lazy loading. Angular.io/guide/lazy-loading-ng modules. RxJS async pipe. Angular.io/API/common/async pipe. Angular state management from official docs. Angular.io/guide/reducing-application-size-state-management. NGRX official site. NGRX.io. NGXS official site. NGXS.gitbook.io. Angular PWA guide. Angular.io/guide/service-worker-getting-started. Angular Universal Guide. Angular.io/guide/universal. This chapter has introduced you to a range of powerful techniques and concepts that are crucial for building high-performance, maintainable, and modern Angular applications. While some of these topics are complex, understanding their purpose and knowing when to apply them will significantly elevate your Angular development skills. In the next chapter, we'll discuss deploying your application and best practices for moving your Angular project from development to a live environment. Chapter 10. Deploying your Angular application. You've built a fantastic Angular application, complete with dynamic components, robust routing, backend communication, and maybe even some advanced optimizations. But what good is a masterpiece if it sits only on your development machine? The final, crucial step in the development process is deployment, making your application accessible to users around the world. This chapter will guide you through the process of building your Angular application for production, understanding the output, and deploying it to common hosting environments. A. Understanding the production build. Before deploying, you need to build your Angular application. The development server, ngserve, is great for rapid iteration, but it's not optimized for production. A production build undergoes several optimizations to make your application faster and smaller. 1. The build command. To create a production-ready build, you use the Angular CLI. ng build configuration equals production or simply ng build prod legacy option. This command performs several critical optimizations. Ahead of time, AOT compilation. Angular compiles your HTML and TypeScript code into highly optimized JavaScript before the browser downloads and runs it. This makes the application faster to load and render, as the browser doesn't need to compile templates at runtime. It also catches many template errors at build time, not runtime. Minification removes unnecessary characters from your code, like whitespace, comments without changing its functionality, making file sizes smaller. Uglification renames variables and functions to shorter names, e.g., long variable name becomes a, further reducing file size. Tree shaking eliminates unused code. If you import a library but only use a small part of it, tree shaking removes the parts you don't use from the final bundle. Bundling combines multiple JavaScript and CSS files into fewer, larger files, reducing the number of HTTP requests the browser needs to make. Dead code elimination removes code that can't be reached or executed. 2. The output directory, dist. After a successful ng build production command, you'll find the optimized application files in a new folder named dist, or dist your project name depending on your Angular JSON config. Inside, you'll see a collection of files, all of which are essential for your production build. Index.html, the single entry point for your SPA. JS files, e.g. main, JS polyfills, JS runtime, JS vendor, JS. These are your JavaScript bundles, containing your application code, Angular framework code, and polyfills. The in the file names, like main.xxx.js, is a hash derived from the file's content. This hash is crucial for browser caching. CSS files, e.g. styles, CSS, your bundled CSS styles. Assets / any static assets, images, JSON files, etc., you've placed in your src/assets folder. Faviconico, your site's favicon. Important, these files are static. There's no server-side processing needed for them directly. This makes Angular applications very easy to host. B. Hosting environments for Angular applications. Since the output of an Angular build is a set of static files, you can host them on almost any web server or static hosting platform. Here are some popular options. 1. Web servers Nginx Apache. Concept: traditional web servers can serve static files. To deploy an Angular app, you simply copy the contents of your dist folder to the web server's document root or a subfolder. Configuration for SPA routing. The key challenge here is handling client-side routing. If a user directly navigates to a deep link like yourdomain.com/recipes/123, the server will look for a file named 123 inside a recipes directory, which doesn't exist. It needs to be configured to always serve index.html for any unmatched path. Nginx example: server listen 80, server name yourdomain.com, root usr/share/nginx/html/your Angular app. Hash path to your dist folder. Location: trifles yuri//index.html. Hash essential for SPA routing. Hash optional. Handle API requests. Hash location/API/. Hash proxipaz http localhost :3000. Hash forward requests to your backend API. Hash. Apache example, using htaccess in your root directory. Rewrite engine on. Hash if an existing asset at that path exists, serve it. Rewrite con %document root %requestory, F or. Rewrite con %document root %requestory, D. Rewrite rule L. Hash if no asset matching the path, serve index.html. Rewrite rule, index.html L. When to use. When you have an existing server infrastructure, need fine-grained control, or are hosting alongside a backend on the same server. 2. Static site hosting services, Netlify, Versal, Firebase Hosting, GitHub Pages, AWS S3 plus CloudFront. Concept: these services are specifically designed for hosting static web applications and often integrate with Git repositories for continuous deployment. They handle the SPA routing configuration automatically or with minimal setup. Netlify/Versal, extremely popular for their ease of use. You connect your GitHub/GitLab/Bitbucket repository, specify your build command, ng build configuration equals production and publish directory, dist your project name, and they handle the rest, including custom domains, SSL, and automatically setting up routing rules for SPAs. Firebase Hosting, Google's hosting solution, well integrated if you're using Firebase for your backend or authentication. Simple CLI deployment, Firebase deploy. GitHub Pages, free static hosting for GitHub repositories. You can configure it to deploy your dist folder from a specific branch or GitHub Actions. Requires extra setup for SPA routing, often a custom 404-page redirecting to index.html with a JS hack. Oz S3 plus CloudFront. AWS S3 for storage, very cheap for static files, and CloudFront as a content delivery network. CDN for fast global delivery and SSL. Requires more manual setup or infrastructure as code. ISC tools like Oz Amplify for simpler deployments. When to use. For most modern Angular applications, especially personal projects, startups, or when you want simplicity and fast deployment. 3. Containerization Docker. Concept: you can package your Angular application and the web server like Nginx that serves it into a Docker container. This creates a portable, self-contained unit that can run consistently across different environments: developer's machine, staging, production. Benefits: consistency, scalability, easy to spin up multiple instances, and integration with orchestration tools like Kubernetes. How it works conceptual: you'd create a Docker file that builds the Angular app, run ng build configuration equals production, copies the dist contents into an Nginx Docker image, configures Nginx inside the container. This produces a single Docker image that contains your entire front end. When to use. For larger teams, complex deployment pipelines, microservices architectures, or when you need consistent environments from development to production. See important deployment considerations. 1. Environment variables. Problem: your application might need different configuration values for development, staging, and production, e.g., API endpoints, authentication keys. You can't hardcode these if they change. Solution: Angular's environments folder, src/environments/environment.ts, src/environments/environment.prod.ts handles this. The build process automatically swaps the environment.ts file with environment.prod.ts, or another environment config, when you specify configuration equals production or configuration equals yorenv. Environment.ts development. Export const environment equals production false. API URL http localhost:3000/API. Environment.prod.ts production. Export const environment equals production true. API URL https api.yourprodapp.com/v1. And in your component service, import environment from src/environments/environment. Security: never commit sensitive production keys or API secrets directly into your source code, even in environment.prod.ts. Use build time variables, CI/CD secrets, or server-side configuration for highly sensitive data where possible. 2. Base href problem. If your Angular application is not hosted at the root of your domain, e.g., it's at yourdomain.com/my-angular-app/. Angular might not know where to correctly route internal links due to the base href equals /tag in index.html. Solution: adjust the base href during the build using the base href flag. ng build configuration equals production base href my Angular app. This changes base href equals / to base href equals /my Angular app/ in your index.html. 3. Browser caching and cache busting. Problem: browsers aggressively cache static assets, JavaScript, CSS. When you deploy a new version of your app, users might still see the old version because their browser is serving cached files. Solution: the default ng build production already handles this well by including content-based hashes in the file names, e.g., mainsize123. JS. When the file content changes, the hash changes, and the browser treats it as a new file, forcing a fresh download. Manual cache clearing. Instruct users to clear their browser cache if they experience issues after a new deployment, though this should be rare with proper cache busting. 4. HTTPS always. Recommendation: always deploy your production application over HTTPS. Browsers often require it for modern web features, like service workers for PWAs, geolocation, push notifications, and it provides security and trust. Solution: most hosting providers, Netlify, Versal, Firebase, AWS CloudFront, provide free SSL certificates. Let's encrypt automatically. If you're managing your own server, use certbot to set up Let's Encrypt. 5. Performance monitoring. Recommendation: integrate performance monitoring tools, e.g., Google Lighthouse, Web Page Test, APM tools like New Relic, Dynatrace, or Sentry for error tracking, to track real user performance and identify bottlenecks after deployment. D. Common pitfalls/troubleshooting, Chapter 10. Blank page after deployment. Problem: often a base href issue or incorrect server configuration for SPA routing. Solution: check index.html's base href equals, and ensure your web server is configured to serve index.html for all valid subroutes. Check browser console for errors. API calls suddenly fail after deployment. Problem: your production build is trying to hit a development API URL or CORS issues if frontend and backend are on different domains. Solution: verify your environment.prod.ts API URL is correct and points to your production backend. Ensure your backend has CORS configured to allow requests from your production frontend domain. Deployment script errors. Problem: issues during CI/CD pipeline or custom deployment scripts. Solution: check the logs of your CI/CD service. Ensure all dependencies are installed, npm install, ng build configuration equals production runs successfully, and the correct output directory is being deployed. E. Further reading/resources, Chapter 10. Angular Deployment Guide. Angular.io/guide/deployment provides general best practices and specific host recommendations. Netlify documentation. Docs.netlify.com. Versal documentation, versal.com/docs. Firebase hosting documentation, firebase.google.com/docs/hosting. Nginx for spas. Numerous blog posts and tutorials available for Nginx configuration for single-page applications. Deploying your Angular application is the final step in bringing your creation to life. By understanding the production build process and choosing the right hosting environment, you can confidently share your projects with the world. You've now completed the journey from understanding the basics to deploying a full-fledged Angular application. The rest is practice, building, and continuous learning. Chapter 11, Understanding Change Detection and Zone.js. You've built and deployed your Angular application, and it likely works just as you expect. Updates to data miraculously reflect in the user interface, often without you explicitly telling Angular to refresh the view. This magic is powered by Angular's change detection mechanism, which uses a library called Zone.js. While often hidden from day-to-day development, understanding how change detection works is fundamental to building performant applications, debugging tricky issues, and mastering more advanced Angular concepts, especially those related to performance we touched upon in Chapter 9. What is change detection? The core problem: web applications are dynamic. User interactions, clicks, typing, network responses, data from APIs, and timers like set timeout or set interval all cause the application's internal data to change. The browser's HTML, the view, needs to synchronize with these changes. How does the framework know when and what to update efficiently? The naive approach: manual updates. In frameworks without automatic change detection, developers might manually update DOM elements after every data change. This is error-prone, tedious, and hard to manage in complex applications. Angular's solution: Angular automatically detects when component data changes and intelligently updates the view. This process is called change detection. It's Angular's way of ensuring that your UI always reflects the current state of your application's data. Be how change detection works, simplified. Angular's change detection happens in cycles. Each cycle involves checking the state of all components, starting from the root component and moving down the component tree to see if any of their data values have changed since the last check. 1. Component tree walk. Angular conceptually traverses the component tree from parent to child. For each component, it compares the current values of its data-bound properties, those used in template expressions like my property, etc., with their previous values. 2. Value comparison. If a value has changed, e.g., a primitive like a number or string or an object reference, Angular marks the component as dirty and schedules an update. 3. DOM update. If a component is marked dirty, Angular updates the relevant parts of the DOM associated with that component to reflect the new data. See the role of Zone.js. While Angular handles how change detection happens, it's Zone.js that tells Angular when to kick off a change detection cycle. Zone.js is a library that patches asynchronous browser APIs. What is a zone? Think of a zone as an execution context that can track asynchronous operations. Zone.js intercepts all common asynchronous tasks in the browser: browser events, click, keypress, submit, input, etc. Timers, set timeout, set interval, network requests, XML HTTP request used by HTTP client, fetch, promises, promise then, promise.catch. How Zone.js triggers change detection. When an asynchronous operation starts, Zone.js notes it. When an asynchronous operation completes, Zone.js triggers a notification to Angular. Angular, upon receiving this notification from Zone.js, initiates a change detection cycle. It assumes that since an async operation just completed, it might have changed some application data, and thus the UI might need updating. This is the magic. This is why you don't have to manually tell Angular to update the view after an HTTP request completes or a button is clicked. Zone.js detects the event, tells Angular, and Angular handles the rest. Change detection strategies. By default, Angular uses the default change detection strategy, which is often sufficient for small to medium-sized applications. However, for larger applications or to fine-tune performance, you can switch to the on-push strategy. One default strategy, change detection strategy. Default behavior. Angular checks every component in the component tree during every change detection cycle, regardless of whether its data has potentially changed or not. This check happens after any asynchronous event, as detected by Zone.js, or any explicit event by Angular itself. Pros: easy to use, just works. No need to worry about immutability. Cons: can be inefficient for very large applications with many components, leading to unnecessary checks and potentially slower performance. 2. On-push strategy, change detection strategy. On-push behavior. When a component is set to on-push strategy, Angular runs change detection for that component and its children only when. And at input, decorated properties reference changes for objects arrays or its value changes for primitives. An event originated from the component itself or one of its children, e.g., a button click within its template. An observable the component subscribes to via a sync pipe or manual subscription emits a new value. You explicitly tell Angular to run change detection, this .changedetectorf .detect changes. Pros: highly performant, as it drastically reduces the number of components Angular needs to check. Cons: requires careful attention to immutability. If you modify an input object array in place rather than creating a new reference, Angular will not detect the change, and your component's view will not update. Immutability example for on-push. If a component receives an array myItems via at input and is on on-push and you want to add an item, incorrect will not trigger on-push update. This myItems push, new item. Reference to myItems remains the same. Correct will trigger on-push update. This myItems equals, this myItems new item. A new array reference is created. When to use on-push. It's a good practice to use on-push for presentational or pure components that primarily receive data via at input and emit events via at output, and don't manage complex internal state directly. For container components that manage complex state or data fetching, default is often fine, or a mix of both can be used. Explicitly triggering change detection, change detectorf. Sometimes, you might need to force a change detection cycle manually. This is rare in typical Angular development, but can be useful in specific scenarios, especially when working with third-party libraries that operate outside of Angular's Zone.js, or when you explicitly want to trigger an update based on complex logic. Inject change detectorf. Import component change detection strategy change detectorf from at Angular core at component selector at my component template URL my-component.component HTML change detection strategy on push example can be used with default too. Export class my component constructor private CDR change detectorf force chain detection update view manually void some data change that Angular might not detect automatically. This .cdr.detect changes. Check this component and its children, or this CDR mark for check. Mark this component for check in the next cycle. Detect changes. Triggers a change detection cycle for this component and all its descendants immediately. Mark for check. Marks the component and ancestors as dirty, ensuring they will be checked in the next change detection cycle. This is usually preferred over detect changes, as it integrates better with Angular's natural cycle. Running Angular without Zone.js beyond this book's scope. For extreme performance or specific use cases, e.g., highly optimized web workers, it's possible to run Angular applications without Zone.js. This removes the automatic change detection triggering. In such scenarios, you would need to manually call cdr.detect changes whenever you expect the view to update. While this offers maximum control, it significantly increases boilerplate and complexity, and is typically reserved for highly specialized performance-critical applications. Most Angular applications benefit from Zone.js's convenience and automatic detection. Common pitfalls / troubleshooting, Chapter 11. View not updating with on-push, problem. Data in the component changes, but the template doesn't update. This is almost always an on-push component coupled with immutable data being modified rather than replaced. Solution. Ensure you're creating new object array references whenever you modify data that an on-push component receives via at input. Performance issues with default strategy. Problem: slow application performance or UI freezing, especially with many components or frequently updated data. Solution: consider implementing on-push strategy starting from leaf components, components at the bottom of the component tree that mostly receive at input data, and working your way up. Use the async pipe generously. Confusing detect changes, V's Mark IV check. Problem: unnecessary performance overhead by calling detect changes too often. Solution: prefer Mark IV check in most scenarios, as it allows Angular to integrate the check into its existing cycle. Only use detect changes when an immediate update is absolutely critical, e.g., animations. Further reading/resources, Chapter 11, Angular Change Detection Guide. Search for official documentation, but also many excellent community articles on the topic. Look for Angular Change Detection Explained or Angular Zone.js Primer. RxJS Async Pipe. Angular.io/API/common/async pipe. Revisit this as it ties directly into efficient change detection. Angular Change Detector Ref. Angular.io/API/core/change detector ref. Official Zone.js repository. github.com/angular/zone.js. Understanding Angular's change detection and the underlying role of Zone.js helps you shed the idea that it's magic and instead see it as a powerful, controllable mechanism. By leveraging this knowledge, particularly by strategically employing the on-push strategy, you can build Angular applications that are not only functional but also highly performant and delightful to use. In the next chapter, we'll dive into another essential aspect of modern web applications: routing guards, which control access to parts of your application based on user roles or other conditions. Chapter 12, Root Protection. Guards and Resolvers. We've mastered how to define routes and navigate through our Angular application. However, in most real-world scenarios, not all routes should be accessible to all users at all times. For example, an admin dashboard should only be accessible to administrators, or a recipe editor page might require the user to be logged in before they can create or modify recipes. This is where root guards come in. They allow you to control access to routes based on certain conditions. Additionally, sometimes you need to fetch data before a component is displayed, preventing the user from seeing a blank screen while data loads. This is where root resolvers are used. Introduction to root guards. Concept: a root guard is an Angular service that implements a specific interface to decide whether a user can activate a root, can activate, deactivate a root, can deactivate, load a lazy loaded module, can load, activate a child root, can activate child. Guards are functions that return a Boolean true for access, false for deny, an observable Boolean, or a promise Boolean. If a guard returns false, navigation is cancelled. If it returns a URL tree, the router navigates to that URL tree instead. Why use guards? Authentication. Prevent unauthenticated users from accessing protected areas. Authorization. Restrict access based on user roles, e.g., only admins can reach admin. Confirmation. Prompt users before they leave a page with unsaved changes. Conditions. Allow navigation only if certain conditions are met, e.g., sufficient network connection. Generating a guard, ng-generate guard. You can generate a guard using the Angular CLI. ng-generate guard auth, or ng-guard auth. The CLI will ask which interfaces you want to implement. For authentication, can activate is a common choice. Can activate guard, authentication example. Let's create a guard that checks if a user is authenticated before allowing them to access the recipe editor. We'll simply assume an auth service exists that has an isAuthenticated method, which might check a token in local storage. 1. Authentication service, conceptual auth service DS. Import injectable from @Angular core. Import observable of from RxJS. Of for immediate observable. @Injectable. Provided in root. Export class auth service. In a real app, this would check local storage for a token, or validate against a backend. Is authenticated, observable Boolean. For demonstration, let's say user is authenticated if they have a user logged in item set. Const logged in local storage get item, user logged in. Console log auth service, is user authenticated, logged in, return of logged in, return an observable. Login, void. Local storage set item, user logged in, true, console log, user logged in. Logout, void. Local storage, remove item, user logged in, console log, user logged out. 2. Creating the authguard TS. Import, injectable from @Angular core. Import, can activate, activated root snapshot, router state snapshot, URL tree, router from @Angular router. Import, observable from RxJS. Import, auth service from auth service. Import our auth service. Import map take from RxJS/operators for RxJS operators. Add injectable, provided in root. Export class, authguard implements can activate. Constructor private auth service private router, router. Can activate. Root activated root snapshot, snapshot of the current root. State, router state snapshot, snapshot of the router state. Observable Boolean URL tree, promise a Boolean URL tree, Boolean URL tree. Console log authguard, checking can activate. Use auth service to check authentication status. Return this auth service is authenticated. Pipe. Take 1, take only the first value emitted by the observable. Map is authenticated equals. If is authenticated. Console log authguard. User is authenticated, navigating to root. Return true, allow navigation. Else. Console log authguard. User is not authenticated, redirecting to login. Redirect to login page and return a URL tree. Return this router create URL tree /login. Can activate requires implementing the can activate method. It injects auth service to check authentication and router to redirect if needed. It uses pipe take 1 map to work with the observable Boolean returned by is authenticated. If not authenticated, it uses this router create URL tree /login to tell the router to navigate to the login page instead of the guarded route. 3. Applying the authguard to a route. In your routing module, app routing module TS, add the can activate property to the route definition. App routing module TS. Import ng module from @Angular core. Import router module routes from @Angular router. Import home component from home.component, assuming you have these. Import recipe editor component from recipe editor recipe-editor.component. Import login component from login.component, assuming you have a login component. Import authguard from authguard. Import your guard. Const routes equals. Path, component, home component. Path edit recipe. Component, recipe editor component. Can activate authguard, apply the guard here. Path, login component. Path redirect to. Add ng module. Imports router module for route routes. Exports router module. Export class app routing module. Now, if a user tries to access edit recipe without being logged in, as per our auth service, they will be redirected to login. See other types of guards briefly. Can deactivate. Purpose. Prevents a user from leaving a route, typically used to confirm if they want to discard unsaved changes in a form. How? The guarded component itself implements an interface, e.g., can component deactivate, which includes a can deactivate method. The guard then calls this method on the component instance. Can load. Purpose, * prevents a lazy loaded module from being loaded at all if the conditions are not met. This is a performance optimization, as the module's code won't even be downloaded if access is denied. How? Applied to the load children property of a route. Can activate child. Purpose. Applied to a parent route, it checks against activation for all its child routes. Useful for protecting an entire section of your application uniformly. Introduction to route resolvers. Resolve. Concept. A route resolver is an Angular service that implements the resolve interface. It's designed to fetch data before a component is fully activated, instead of fetching data in ng on init of your component, which might show a blank screen or loading spinner while data loads. A resolver ensures the data is available before the component even initializes. Like guards, resolvers return a promise, observable, or raw data. Why use resolvers? Improved user experience. Prevents flickering or blank states by delaying component activation until essential data is ready. Prefetching data ensures the component has all it needs to render immediately. Error handling. Resolvers can also handle errors during data fetching, potentially redirecting to an error page instead of activating a component with missing data. Generating a resolver. ng generate resolver. ng generate resolver recipe or nggr recipe. resolve guard fetching recipe details example. Let's create a resolver that fetches a single recipe's details by ID before the recipe detail component is displayed. 1. Creating the recipe resolver TS. Import injectable from @Angular core. Import resolve activated root snapshot from @Angular router. Import observable of from RxJS. Import recipe service from recipe service, our recipe data service. Import catch error from RxJS/operators. Import recipe from recipe model. Assume recipe interface. Add injectable. Provided in root. Export class recipe resolver implements resolve recipe null. Specifies what it resolves to. Constructor private recipe service. Recipe service. Resolve route activated root snapshot. Observable recipe null. Const id equals number route param map get id. Get the ID from root parameters. If is not an ID. Console error recipe ID is not a number. Route param map get ID. Return of null or redirect to an error page. Console log recipe resolver attempting to fetch recipe with ID. id fetch recipe using the service. Return this recipe service get recipe by ID pipe. Catch error equals console error recipe resolver. Failed to fetch recipe error. Handle error e.g. navigate to a 404 page show alert. This router navigate /recipe not found. Return of null. Return null or an empty object or throw error. Resolve recipe null specifies the type of data the resolver will provide. Resolve method injects activated root snapshot to get root parameters. It uses recipe service get recipe by id, which returns an observable. Catch error handles potential errors during data fetching, preventing the whole navigation from failing. 2. Applying the recipe resolver to a route. In your routing module, use the resolve property. App routing module TS. Imports for components and services. Import recipe resolver from recipe resolver. Import your resolver. Const roots equals path recipe/ID. Component recipe detail component. Resolve recipe resolver. Assign the resolver to a key recipe. The resolve property is an object where keys are the names the data will be available under, and values are the resolver services. Here, the data resolved by recipe resolver will be available as recipe. 3. Accessing resolved data in the component. In the recipe detail component, the resolved data is available via the activated root's data observable. Recipe-detail.component TS. Import component on init from @Angular core. Import activated root from @Angular router. Import recipe from recipe model. Assume recipe interface. At component, selector app recipe detail. Template URL. Recipe-detail.component HTML. Style URLs. Recipe-detail.component CSS. Export class recipe detail component implements on init. Recipe null equals null. Will hold the resolved recipe. Constructor private root activated root. ng on init void. Console log recipe detail component ng on init starting. Access the resolved data via the data observable from activated root. This route data subscribe data. This recipe equals data recipe. Recipe is key from the routing module. Console log recipe detail component. Resolved recipe data. This recipe. No need to fetch data from service directly in ng on init anymore. Now, when a user navigates to recipes 123, the recipe resolver will fetch the recipe. The recipe detail component will only be created and initialized once that data is successfully loaded, or if the resolver returns null or redirects. Common pitfalls / troubleshooting, Chapter 12. Forgetting to provide guards resolvers. Problem: no provider for guard resolver name. Error. Guards and resolvers are services and must be provided to the dependency injection system. Solution. Ensure provided in. Root is in there at injectable, decorator, or less common, list them in the provider's array of your ng module or a specific feature module. The CLI usually sets provided in. Root automatically for newly generated guards resolvers. Misunderstanding return types. Problem. Returning a non-Boolean for guards or non-observable promise for resolvers will cause errors. Solution. Ensure your can activate, can deactivate, resolve methods return types match the interface requirements. Boolean URL tree, observable Boolean URL tree, promise-a-Boolean URL tree for guards. Observable T, promised T for resolvers. Resolver data not available. Problem. If a resolver encounters an error, e.g., HTTP 404, and you don't catch error and return a valid type like of null or a fallback object, the navigation might simply stop without an error message or the component won't activate. Solution. Always include robust error handling with catch error in your resolver's observables to ensure they always return a value or a URL tree for redirection. Overuse of guards resolvers. Problem. Using guards resolvers for every small data fetch or simple condition can add unnecessary complexity to your routing configuration. Solution. Reserve guards for true access control. For data fetching, a resolver is good for initial critical data. For secondary data or data that can load after the component is rendered, fetching it within ng on init, with loading spinners, is still a valid approach. Further reading/resources, Chapter 12. Angular Router Guards. Angular.io/guide/router-tutorial-heroes #preventing-unauthorized-access official tutorial. Angular root resolvers. Angular.io/API/router/resolve API documentation example. More comprehensive guides on authorization and authentication in Angular. These often build on guards and combine them with authentication flows. Root guards and resolvers are powerful features that enable you to build professional-grade Angular applications with controlled navigation and better user experience. They bring order to your application's flow, ensuring that users only see what they should and that critical data is ready when a view appears. In our final technical chapter, we'll explore the often overlooked benefits and techniques of accessibility in Angular. Chapter 13. Accessibility A11Y. Building inclusive applications. As developers, our goal should always be to create applications that are usable and enjoyable for everyone, regardless of their abilities. This principle is called accessibility, often abbreviated as A11Y, because there are 11 letters between A and Y. Building accessible web applications isn't just about compliance or good practice. It expands your audience, improves usability for all users, and often leads to higher quality code. This chapter will introduce you to the core principles of web accessibility and provide practical tips and Angular-specific techniques to ensure your applications respect and support diverse user needs. What is web accessibility? A11Y? Definition. Web accessibility means that websites, tools, and technologies are designed and developed so that people with disabilities can use them. More specifically, people can perceive, understand, navigate, and interact with the web. Contribute to the web. Who benefits? Accessibility benefits a wide range of people with disabilities, including visual impairments. Blindness, low vision, color blindness rely on screen readers, magnifiers, high contrast. Auditory impairments, deafness, hard of hearing rely on captions, transcripts. Motor impairments, difficulty using a mouse, keyboard, or having tremors rely on keyboard navigation, voice control, switch devices. Cognitive impairments, learning disabilities, ADHD, memory disabilities rely on clear language, consistent navigation, simplified layouts. Situational disabilities, anyone can experience a temporary disability. Think of using a mobile phone in bright sunlight visual, navigating a noisy environment auditory, or holding a baby while trying to use a one-handed device motor. Legal and ethical considerations. Many countries have laws, like the Americans with Disabilities Act in the US or the Equality Act in the UK, that require websites to be accessible. Beyond legal compliance, it's simply the right thing to do to ensure equal access to information and services. B. Core Principles of Web Accessibility, the POUR Principles. The Web Content Accessibility Guidelines, WCAG, are the international standards for web accessibility, structured around four main principles. Perceivable, information and user interface components must be presentable to users in ways they can perceive. Is your content available to senses other than sight, e.g., text for screen readers, audio descriptions for videos? Is there enough contrast for text? Is information conveyed by color also conveyed in another way? Operable. User interface components and navigation must be operable. Can users navigate and interact without a mouse, keyboard-only navigation? Is there enough time to read and use the content? Are complex animations controllable or stoppable? Are predictable navigation and consistent locations used? Understandable. Information and the operation of user interface must be understandable. Is text readable and clear? Is the content predictable, e.g., does clicking a button always do what's expected? Do forms provide clear instructions and error messages? Robust. Content must be robust enough that it can be interpreted reliably by a wide variety of user agents, including assistive technologies. Does your code adhere to web standards? Is the content compatible with current and future user agents, including assistive technologies? See Angular-specific A11Y techniques and best practices. Angular doesn't magically make your application accessible, but it provides tools and encourages structures that support good accessibility practices. 1. Semantic HTML. Principle. Use HTML elements for their intended meaning. Angular context. Instead of using non-semantic div elements everywhere, prefer header, nav, main, footer, section, article, aside, button, input. Screen readers and other assistive technologies rely on these semantic tags to understand the structure and purpose of content. Example: use button for clickable actions, not div click equals do something. Use nav for navigation links. 2. Keyboard navigation. Principle: all interactive elements must be reachable and operable using only the keyboard, tab, shift plus tab, enter, spacebar, arrow keys. Angular context. Focus management. When components mount or change, e.g., after routing, ensure logical focus is placed where expected. Angular's router manages focus reasonably well for whole page changes, but for partial updates, e.g., opening a modal, you might need to manually set focus using elementref and renderer select root element. Focus. Tab order. Ensure the natural tab order tab index makes sense. Interactive elements, buttons, inputs, links are naturally focusable. If you create custom interactive elements, give them a tab index equals 0. Skip links. For pages with lots of repetitive navigation, like a large header, add a skip to main content link at the top, usually hidden off-screen until focused. 3. ARIA attributes, accessible rich internet applications. Principle: ARIA provides additional HTML attributes that define ways to make web content and web applications more accessible to people with disabilities. They fill gaps in semantic HTML, especially for complex UI patterns like tabs, accordions, dialogues, and dynamic updates where native HTML isn't sufficient. Angular context. You can apply ARIA attributes directly to your HTML elements in Angular templates using property binding. Example: for a custom toggle button that doesn't have a native checkbox role, div role equals switch, @area checked equals is toggled, click equals toggle. For a dynamic region that updates, div area live equals polite new content loaded, /div screen readers will politely announce changes in this region. Caution: only use ARIA when native HTML semantics don't suffice. No ARIA is better than bad ARIA. Always test with assistive technologies. 4. Alternative text for images, alt attribute. Principle: provide concise, descriptive alt text for all meaningful images. Screen readers read this text aloud. Angular context. img src equals recipe image URL, alt equals image of plus recipe title. If an image is purely decorative, assign alt equals empty string, so screen readers skip it. 5. Form accessibility. Principle: Ensure labels are correctly associated with input fields, provide clear instructions, and make error messages discoverable and understandable. Angular context, for and id attributes. Always use label for equals input ID paired with input id, inputted. Validation messages. As seen in Chapter 7, validation messages need to be perceivable. Use area_described_b to link an input to its error message div label for equals recipe title label. Input type equals text, ID equals recipe title, form control name equals title. @array invalid equals add recipe form get title, invalid. @area_described_b equals add recipe form get title, invalid. Title error, null, div *ng if equals add recipe form get title, invalid, and an add recipe form get title, touched. ID equals title error, class equals alert danger title is required. Div. This tells the screen reader the error message, title error, describes the input recipe title. 6. Color and contrast. Principle. Ensure sufficient contrast between text and background colors. Avoid conveying information solely through color. Angular context. This is primarily a CSS concern, but Angular material, a UI component library, comes with accessibility built in, including adherence to WCAG contrast ratios. 7. Dynamic content and live regions. Principle. When content dynamically changes, e.g., loading indicators, real-time updates, search results, users of assistive technologies need to be informed. Angular context. Utilize AreaLive attributes for dynamically updated regions. Div AreaLive equals polite your order has been placed successfully /div. 8. Angular material and accessibility. If you're using Angular material from Chapter 9's performance discussion of component libraries, many accessibility concerns are handled for you, as it's built with WCAG standards in mind. However, using material doesn't absolve you from ensuring your custom content and interactions are accessible. D-testing for accessibility. Building accessible applications requires testing with the tools people with disabilities use. 1. Keyboard-only navigation. Unplug your mouse and try to navigate your entire application using only the Tab key, Shift plus Tab, Enter, and Spacebar. Can you reach all interactive elements? Is the focus order logical? Can you activate everything? 2. Screen readers. Test your application with a screen reader. NVDA non-visual desktop access, free for Windows. VoiceOver, built-in on macOS and iOS. TalkBack, built-in on Android. Can you understand the content? Are interactive elements announced correctly? 3. Browser extensions. Lighthouse, built into Chrome DevTools, has an accessibility audit. Axe DevTools, a powerful browser extension for automated accessibility testing. WebAIM Wave, another useful web accessibility evaluation tool. 4. Color contrast checkers. Tools like WebAIM's contrast checker help verify sufficient color contrast. Common pitfalls / troubleshooting, Chapter 13. Over-reliance on div and span. Problem. Using non-semantic elements for interactive content without proper ARIA roles. Solution. Prioritize semantic HTML. If you must use div or span for a button, make it focusable tab index equals 0 and assign role equals button, and ensure it responds to both mouse clicks and keyboard enter space. Missing or generic alt text. Problem. Images with img src equals, alt equals, when they convey meaning, or alt equals image, which is unhelpful. Solution. Craft concise, descriptive alt text for meaningful images. If purely decorative, alt equals. Focus traps. Problem. Keyboard users get trapped in certain sections, e.g., a modal dialog and cannot tab out. Solution. Use proper modal implementation that controls focus, ensuring it's constrained within the modal when open and returns to the triggering element when closed. Insufficient contrast. Problem. Text is hard to read due to low contrast with the background. Solution. Use color contrast checker tools throughout your design and development process. Further reading / resources, Chapter 13. Web Content Accessibility Guidelines, WCAG, Overview. w3.org/WAI/standards-guidelines/WCAG/ The Foundational Guidelines. WebAIM, Web Accessibility in Mind. WebAIM.org, Excellent resources, articles, and tools. Google's Web Fundamentals, Accessibility. developer.chrome.com/docs/lighthouse/accessibility. A11Y Project. A11yproject.com, community-driven effort to make web accessibility easier. Angular Accessibility Guide. The Angular team provides some accessibility guidance, often through examples in Angular material. Building accessible applications is an ongoing journey, not a one-time task. By integrating accessibility practices from the start, considering diverse user needs, and regularly testing with appropriate tools, you'll create Angular applications that are not only powerful, but also truly inclusive and user-friendly for everyone. This dedication to thoughtful development is what truly distinguishes a professional developer. In our concluding chapter, we will summarize your journey and provide guidance for continued learning and growth. Chapter 14. Next Steps and Continuous Learning. Congratulations! You've reached the end of Angular Ascent. You've embarked on an incredible journey, starting from the foundational concepts of modern web development and working your way up to building sophisticated Angular applications. You've covered everything from components and data binding to routing, services, forms, testing, performance, state management, and even inclusive development with accessibility principles. That's a lot to absorb, and by actively engaging with the material, you've equipped yourself with a powerful toolkit. This final chapter serves as a wrap-up, summarizing your journey, and more importantly, providing guidance on how to continue your growth as an Angular and web developer. The landscape of web development is constantly evolving, and continuous learning is the key to staying current and excelling. Your journey so far? A recap. Let's quickly review the key milestones you've achieved. Foundation, Chapters 1 to 3. You understood the evolution of the web into SPAs, chose Angular for its robust features and structured approach, set up your development environment, and built your first app. You then dove deep into the core building blocks: components, their templates, the power of data binding, and the elegance of directives and pipes for dynamic content and display formatting. Interaction and Structure, Chapters 4 to 5. You learned how components talk to each other using at input, for parent-to-child data flow, and at output, with event emitter for child-to-parent communication. You then mastered the Angular router to navigate your SPA seamlessly, define routes, pass data through parameters, and perform programmatic navigation. Data and Forms, Chapters 6 to 7. You connected your front-end to the world, using services to encapsulate business logic and HTTP client for making HTTP requests. Get, post, PUT, delete, to backend APIs. You then empowered users to input data with reactive forms, handling powerful validation and providing a structured approach to user input. Robustness and Quality, Chapters 8 to 9. You delved into the crucial architectural pattern of dependency injection, understanding how it underpins Angular's modularity and testability. You then learned how to write unit tests for components and services, ensuring your application's quality and stability. Chapter 9 introduced advanced topics like performance optimization, e.g., on-push strategy, lazy loading, a sync pipe, the importance of state management, and a glimpse into progressive web apps, PWAs, and server-side rendering, SSR. Deployment and Inclusivity, Chapters 10 to 13. You brought your application to life by learning how to deploy it for production, understanding the optimized build process and various hosting options. Finally, you embraced accessibility, A11Y, recognizing its importance and equipping yourself with practices to build inclusive web applications for everyone. This comprehensive overview highlights the breadth of knowledge you've gained. Take a moment to appreciate how far you've come. Be continuing your learning journey. The world of web development is fast-paced. New tools, libraries, and best practices emerge constantly. To remain a proficient and valuable developer, continuous learning is not an option, it's a necessity. One build, build, build. Practice is key. The single most effective way to solidify your knowledge is to build projects. Expand your recipe book, add more features, user authentication, login, logout, user profiles, search and filtering for recipes, recipe submission with image upload, user comments ratings for recipes, shopping list generation from recipe ingredients. Implement the auth guard or recipe resolver that you discussed. Start new projects. Think of an idea that interests you, e.g., a simple task manager, a budget tracker, a weather app clone, and build it from scratch using Angular. The challenges you face will force you to research and learn. Contribute to open source. Find an open source Angular project on GitHub and contribute. This is an excellent way to learn from experienced developers, understand best practices, and get real-world experience. 2. Dive deeper into core technologies. While Angular abstracts much away, a strong understanding of its underlying technologies will make you a much better developer. TypeScript. Explore more advanced TypeScript features. Utility types, advanced generics, decorators, type guards. TypeScript is a powerful language that will serve you well beyond Angular. RxJS, reactive extensions for JavaScript. You've used observables from RxJS with HTTP client and a sync pipe. RxJS is critical for handling asynchronous operations and events in Angular. Deeper understanding of operators, map, filter, switch map, merge map, debounce time, etc. will unlock powerful patterns. JavaScript is next. Stay updated with the latest ECMAScript features. 3. Explore advanced Angular concepts. State management libraries. If you face complex state issues, proactively learn a dedicated state management library like NGRX or NGXS. They represent a significant paradigm shift, but are powerful for large applications. Custom directives and pipes. Learn how to create your own custom attribute and structural directives and more complex custom pipes. Animations. Angular provides a powerful animation module to create smooth, high-performance UI transitions. Internationalization, I-18N. Make your application available in multiple languages. Accessibility, A11Y in depth. Go beyond the basics discussed in Chapter 13. Learn more about ARIA roles, states, and properties, and how to conduct thorough accessibility audits. Testing strategies. Explore E2E testing with Cypress or Playwright. Learn about testing different types of code, e.g., pipes, guards, resolvers. 4. Stay connected with the community. Official Angular documentation. Angular.io is your ultimate source. Always refer to it first for canonical information. Angular blog. Follow the official Angular blog for announcements, new features, and deprecations. Community forums and Q&A. Stack Overflow, Reddit, e.g., r/Angular, and Discord channels are great places to ask questions and learn from others. Conferences and meetups. Attend local Angular meetups or watch recordings of major conferences, Angular Connect, ngConf. YouTube channels. Many content creators provide excellent Angular tutorials and deep dives. Blogs and newsletters. Subscribe to prominent Angular blogs and newsletters. 5. Consider the full stack. While this book focused on Angular frontend, remember that most web applications have a backend. Learn a backend framework, e.g., Node.js with ExpressNest.js, Python with Django/Flask, Netcore, Spring Boot. Understand databases, SQL like PostgreSQL/MySQL, NoSQL like MongoDB, Firebase, Firestore. Learn about REST-TFL APIs and potentially GraphQL. C. The mindset of a modern developer. Embrace change. The web evolves rapidly. Tools, libraries, and best practices change. Don't be afraid to learn new things or adapt to improvements. Read the documentation. This is your primary source of truth. Get comfortable reading official documentation. Understand the why. Don't just learn how to do something. Strive to understand why a particular approach or technology is chosen. This builds deeper knowledge. Debug effectively. Master your browser's developer tools. Learn how to debug. JavaScript. Inspect network requests and analyze performance. Write clean code. Focus on readability, maintainability, and modularity. Your future self or your colleagues will thank you. Ask for help. Don't get stuck for hours. If you've tried to solve a problem and are truly stuck, ask for help from the community. And when you learn something new, help others. Final thoughts. Learning Angular is about more than just syntax. It's about adopting architectural patterns, understanding how a modern reactive application functions, and a mindset of continuous improvement. You've now taken a significant step in your development journey. The path ahead is full of exciting challenges and opportunities. Keep building, keep learning, and enjoy the process of bringing your ideas to life on the web. Go forth and build amazing things.